Hey everybody, welcome back to Electrical Code Academy. My name is Paul Abernathy. I'm your instructor for today, and thanks for joining me. Today we're going to continue our knowledge in understanding services and service conductors and wiring and clearances. And on today's episode, we're going to kind of cover three topics. So this is going to maybe be not too awful long, but we're going to make sure that we cover three important topics today about clearances for service conductors and things like that, and maybe get rid of some of the myths that people may have. But hey, before I do that, I want to remind you that if you really want to learn the National Electrical Code and not just dabble in it, not just go to the social medias and post something you think is code, but you really want to kick your game to the next level. You want to not be just a good electrician who knows how to bend conduit and pull wire, but you want to become a great electrician. And all great electricians understand and have a drive to learn the National Electrical Code. If you want to do that, we've got the program for you. There is no program out there better than ours. If you want to pass an exam, you just want to be better at your trade, you want to be a leader, then you want to get in our Fast Trax program with all of the competency reviews that I personally grade every single one of them and give you feedback. And if you want that and you want to join us on Wednesday nights and really get engaged in learning code and how to dissect questions and ask any codes, I'm basically there to be a consultant for you. If you have any questions, then do me a favor. Go right here. Go to fasttracksystem.com. Choose a course. Watch our demo. The demos are on every page of the programs, generally all of them. If you're doing exam prep, then it's Fast Trax Black. Or the Fast Trax Plus. The Plus basically gives you 12 months access to our exclusive video platform, which is Fast Trax Tube. So it's included in there. That's what the Plus is all about. But you can watch a demo on that. Or maybe you're licensed already and you want to really deep dive into residential, commercial, or even industrial wiring. We have courses on that really deep dive. Maybe your drive is to learn more about grounding and bonding. Well, we have an excellent course on grounding and bonding. And most people know I serve on Code Panel 5. And so we deal with Article 250 as well as Article 200. And so that's where we spend most of our time when we're doing code panel review, is really digging into things about grounding and bonding. So if that's something that you're weak in, then you most certainly want to check that out. So just go to our website and just take a few minutes, look around, see what you like. If you got any questions, there's a comment button up there. You click it, send me a comment. I'm more than happy to help you out and give you some direction. But we're here to make sure that you learn the National Electrical Code. That's what Coffee Hour is all about. So hopefully you get something out of every one of these little videos that we put out, and you do think about going over and joining the Fast Trax system. Become part of the Fast Trax family. We also have a chat feature. We have a message board. We have so many ways to support you. It's not about just books. It's not about DVDs. It's not about watching a random YouTube video. We love code, and we make it interesting. So I want you to join our family. So if you get an opportunity to check it out, please do. Okay, enough of that commercial. Let's kind of get into the course. We're going to talk today about service wiring clearances first. Then we're going to talk about clearances in general, like clearance to balconies, clearances of windows, when you have service conductors. And we're going to answer some of those myths that people may have on the subject as well. So let's go on and get into it. All right, so we're going to start this journey. Obviously, we are in our Fast Trax program. Again, if you're interested in it, you can go to fasttracksystem.com and watch our demo, learn about all the features you have, the built-in flashcards, all the good stuff. But this happens to be out of Unit 10, and we're talking about service wiring clearances. Okay, so let's kind of look at it a little bit and see if we can't raise the education level of everybody that may be watching this. All right. 10-3A, conductors clearance over flat roofs. So majority of the commercial buildings have a flat roof, and you may have service conductors that come from the service drop down to a weatherhead with a mast. And you have to make sure that if it's an accessible roof and it's flat, that you have to make sure that I have a certain amount of clearance above it, okay? So let's kind of go look at it. So we have these great illustrations, and by the way, our entire program is made up of all these different illustrations and call-outs to kind of get you into the topic, summarizes it for you, but also gives you code references. And if you haven't heard me talk about it before, anytime you see a code reference that's between these little chevrons, you want to stop what you're doing, and you want to go to the code book and read it. Even though we might paraphrase something, you really need to go, and that's kind of the secret to our program. It's to work you in and out of the code book, not just to give you something you read and you don't know when to leave the material and go to the code book. You needed some guidance. You need some guidelines. And so that's why we have the chevrons. So what you do is you read it, and then you stop and you go to the code book and you read the code section. Then you come back, and it just makes things so much clearer and easier to understand. Plus, what else is it doing? It's teaching you to maneuver throughout the NEC. And that's what we're trying to do, is to get you to maneuver through the code, at least raise that comfort level of maneuvering. All right, so here we're looking at A. So A is right here. It says, the service mast shall be strong enough to safely withstand the strain imposed by the service drop or overhead service conductors. Supplemental braces or guy wires may be necessary. Okay, so in this case, clearance above the roof, they were needing to maintain the clearance, and so they raised up the actual weatherhead on a mast, not only to have our clearance, right, but if it's up too high, they had to make sure that they have to put guy wires in, right? So all of that stuff. So we'll go look at that. So you see 230.28a. What you're going to do is pause and go look at it. But don't do it now. Don't do it now, because we're going to do it. We're going to go to 230.28a and kind of look at these guy wires real quick. All right, so I'm over here in the code, and I'm going to 230.28. So we'll go back a little bit. And we're going to go right here. Okay, so service masts and supports. Okay, so all this information is basically what we regurgitated, but let's talk about this strength. All right, obviously you're not going to extend PVC up, right? Heat of the day, bends, that tension from the service drop, obviously that's not going to happen. Again, so where the mast is actually supporting the drop, if it's utility service drop, or if you're the electrician and you ran the overhead service conductors, right? And we will talk about that. If you don't know the difference between overhead service conductors, service drops, service laterals, underground service conductors, service entrance conductor, if you don't understand all that, go to Article 100. It's pretty self-explanatory, but we obviously are going to have a video coming up on that. As you can see, I promised folks out there we had tons of videos coming. They're coming, and we're going to be breaking all these things down for you. And they're supplemental to our Fast Trax program. So our Fast Trax program is the key. But here we want to do some supplemental stuff and kind of help solidify the learning process. So here we are over in the code. It says, the service mast shall be of adequate strength or be supported by braces and guy wires to withstand safely the strains imposed by the service drop or overhead service conductors. Hubs intended for use with conduit that serve as a service mast shall be identified for use as service entrance equipment. Now, talk about the strain. Now, it says adequate strength. Who determines what's adequate strength? Well, a lot of times the utility companies will tell you what they expect you to use. They'll say whether you're supposed to use rigid or IMC. Obviously, those have adequate strength. You know, whether EMT has adequate strength or not, again, it's going to be subject to the AHJ determining that strength. But in most cases, what we see is rigid or intermediate. Okay. Now, can anybody tell me, incidentally, what's wrong about this picture? Let me go back to it real quick. I just can't help it because I don't do the illustrations, even though they're great. I always like to bring things out. Anybody notice something here kind of weird? Yeah, notice that the service conductors run through the building. They're supposed to be on the outside of the building. Okay, you can't have service conductors running into the building. But in all fairness to this illustration, maybe this raceway is encased in 2 inches of concrete all the way down. Okay, just to be fair. But it's kind of little things that I notice. And again, everybody can be critical of everything. And again, that's just the nature of where we are. But again, we're using this to illustrate a point. Okay, so not really to nitpick the picture, but it's still a great graphic. Okay. Next, let's go, and that was B right here, and that is overhead service conductors shall not be readily accessible, and that is 230.24. Okay, since we're here, we might as well look at it. There are chevrons, and I want to get you used to doing that. Get you used to stopping in your code and going. So here's your clearances right here, and you'll see right here it says conductors shall have a vertical clearance of not less than 8 feet above the roof surface. Okay, now there are some allowances for reduction of clearance. We'll cover that in another video, but basically it's 8 feet like you see in the illustration that we had. There are some exceptions, like when you have a roof pitch that is 412 or greater, okay, it's pretty steep, then you can reduce it down to 3 feet clearance. But again, generally speaking, 8-foot clearance unless any of the exceptions apply. You have to make sure that we have that, okay? All right, so let's kind of get back here. So that's where we went for that. Remember, chevrons, pause, go look it up. I'll take this off real quick. All right, now let's look at C. What is C pointing out right here? Okay, right here, just what we just did. Conductors must have a minimum clearance of 8 feet above the roof surface, all right? Also, where does this apply? Where does this 8 feet? Is it just above the surface? Does it apply? So that's when we got to look at D. D, it says the vertical clearance above roof level must be maintained for a distance of at least 3 feet from all edges of the roof. Okay, now that's covered in 230.24a. Okay, we saw that, but we didn't go that far, so let's go on and finish that off. Let's go back. Just go back. Doesn't matter. Again, we're going to dissect these things right here. So we stopped at that 8 foot, but here is where it said the vertical clearance above the roof shall be maintained for a distance of at least 3 feet in all directions from the edge of the roof. Okay, so what does that mean for us? Well, this 8 feet, by the way, this 8 feet comes out 3 feet. Right here, see my mouse right here? It comes out 3 feet, then up 8 feet. And so you kind of think of this whole roof, it encompasses this whole roof, but it extends out 3 feet beyond the perimeter of the roof. So it's out 3 feet and up 8 feet. So it's basically like putting a cap on top of it, if you will. So that's where you have to maintain this clearance. And it has to be, starts at the 3 feet from the roof. And it has to be at that 8 feet and maintain that all the way to the point of attachment, okay? So that's kind of the general rule. We're not talking any of the exceptions in this episode. That's kind of the general rule for that, all right? Now, people say, well, I would like to get deeper in all that. Well, our courses do get deeper in all that if you're in the Fast Trax program. But here it says the vertical clearances of overhead service conductors covered in 230.24 pertain to every type of occupancy. Okay, so it's not just commercial. Maybe we see a rooftop here, but this also applies to dwellings as well. So again, don't think that we're looking at this and this is only commercial driven because it shows a picture of, say, a commercial building. No, this is all occupancies that this rule is going to apply to, okay? And then refer to Unit 9 in this book or this course for detailed illustrations explaining vertical clearances. So in Unit 9, remember I told you we're going to have other units, and if you're in the Fast Trax, Unit 9 will show you sloped roofs, flat roofs, all of those type of clearances are covered in that unit. So it's going to be so easy for you to understand it if you're in the Fast Trax program. And again, this is low-hanging fruit, I like to call it, for electrical exams. And if you go over this stuff, then it's right here. So if you use the 3-wave method that I created more than 20 years ago, if you go with the 3-wave method and my specific way of doing it, and we have a video available for that. You just go search for it on YouTube or even on Fast Trax Tube. And if you follow that, as you're going through it, you're going to see these questions that you just know the answer to. And if I take a question is basically you're allotted 2.5 minutes per question, but I can answer it in 5 seconds because I have that knowledge. Look at all the extra time you're going to build up for use on the much harder questions. And that's the method to the madness. The Fast Trax program is trying to teach you things that you can remember, practical things, the more important things that come out of the code. We can't teach you everything in this document. This is a thick document, right? The code. Let me show you here, folks. Y'all seen this. This right here, this is a thick book, right? And the text is really small. So that means it covers a lot of content. There's no way we can cover all of this, but we can teach you the skills to be able to navigate that book. And along the way, teach you a lot of stuff that you'll remember. And that's our goal. And that's called ballistic training. And that's kind of our approach to these chevrons and going to the code and back and forth and back and forth. All right. So I said we're going to do multiples in this unit, so we definitely are going to now get into clearances from openings. Again, we're talking service conductors. Now, when it comes to the openings, a couple things to remember. We are not talking about EMTs. We're not talking about rigid conduit. We're not talking about intermediate conduit. We're not talking about SE cable that has a sheathing or a jacketing covering. We're talking about the open conductors like from a service drop. And once they come out of that bundle, which is a multi-conductor cable, it's plexed at the manufacturer. Once it separates, now you have open service conductors or individual conductors. But in a lot of buildings, you also have steel drops that come down that have separate service conductors that come down. Okay, we call those open service conductors. So the key to this clearance from openings has everything to do with multi-conductor cables without a covering or jacket, or the individual service conductors as they may come out of that assembly, even at the point of attachment where they separate. Those are individual service conductors, and we have clearances we have to keep away from. So let's look at that. Again, great illustrations. So let's look at A. A is pointing right here to the 3 feet. So here's our service drop right here. And we see it's connected to the side of the building. It says open service conductors or multi-conductor cables. This could be a service drop cable. Okay, it has no outer covering. It's not. They're just exposed conductors. It says must have a clearance of at least 3 feet from windows designed to open. That's important. Doors, porches, balconies, ladders, stairs, fire escapes, and similar locations. Where is that covered? 230.9a. That's a chevron. Pause your video. Go look it up to get a more healthier understanding of how this rule reads, especially because you're going to be flipping through it as you do an exam or in the real world, in the field, where it's really critical. You want to make sure that you get used to that going back and forth. Obviously, we've talked about that quite a bit. But the 3 feet clearance from windows that are designed to open, this doesn't apply to a window that is fixed, that is not designed to open. It doesn't apply to those. Also, it doesn't apply to the area above a window that's designed to open. It applies to the left of the window, to the right of the window, up to the very top of the window, but not above the window. And it also applies in front of the window and also applies below. So it's 3 feet in all directions except for above the window. Okay? And remember, it does not apply to fixed windows that do not open. And that same 3 foot clearance applies again to doors, balconies, porches, ladders, all that kind of stuff. So let's kind of look at this illustration A right here. Okay, so here's a balcony. Here's a balconies here. Okay, and it says balconies right here. Okay, here's the ladders. But you see it's more than adequate here. It's at least 3 feet from any of that stuff. Now, if it had been a window right here, then that would be a problem, right? There would be an issue. Now, if that window was right here, but it was a fixed window, maybe just a round viewing window or something that's not designed to open, then that would not be an issue, okay? It's got to be a window that's openable or designed to open, okay? Now, let's look at B. So B is talking right here. So this is a clearance. Public streets, alleys, parks, parking areas subject to truck traffic and non-residential driveways require a minimum vertical clearance of 18 feet. Now that's in 230.24b4. Okay, so I'm going to highlight this because I want to talk about a point here that's really important for us to understand. Now I'm going to look at the notes first, and then we'll come back to look at this because I want to point out something because we are going to go to that. And if you got your code books, you can go on and go to 230.24b and wait for me to get there. But I'm going to get there. Because I want to talk about this clearance thing. Without getting too deep in clearances, we're going to obviously cover that in a different video and cover all the different clearances. But I want to talk about that one for a second. But let's look at this note real quick. So the note says, where a building exceeds 3 stories or 50 feet, okay, in height, branch circuits and feeder overhead lines must be arranged where practicable so that a clear area of at least 6 feet wide will be left adjacent to the building or beginning within 8 feet to facilitate the raising of firefighter ladders. Okay, that's 225.19a. So this has to do when your building's going a certain height, and now you have to clearance for things like rescue ladders and if there's a fire or whatnot. So this applies to the height of the building. That's all covered in 225.19e. Pretty straightforward to make sure that you have those clearances. That's a different clearance than what we're talking about from grade, right? That's in clearance specifically here. And again, where does it begin? It begins at 8 feet. right? And again, it goes up to the 50 feet or higher if it exceeds 3 stories or 50 feet. And so the clearance area is 6 feet wide. Okay, so you have to make sure that clearance there. All right, but let's talk about this here real quick. So take your code books. Let's go to 230.24B4. I'm going to go there. And we're already here, obviously, because we were on clearances. So remember, .24 seems to be clearances, right? But you'll notice that when it talks about clearances here, notice what it says. It says overhead service conductors. It does not say service drops. That's an important distinction, folks, because if you go look at Article 100 and look at the definition of service drops, this is typically controlled by the utility, and they dictate the height and clearances. Now, most of the time, they're going to mirror the NEC, but they dictate that. So when you install your point of attachment and your securement to the building, while it's not necessarily the NEC's responsibility for these clearances on service drops, you have to make sure, because obviously you got to meet the utilities requirements too, or they're not going to bring the service to your building. Now, you might have an inspector who's arguing about clearances because it's service drops, but that's not what 230.24 is all about. That's about overhead service conductors. So you might be saying to yourself, well, what the heck is an overhead service conductor if it's not a service drop? That's why definitions are so important in Article 100. Now, let me give you a scenario on this building. So let me kind of, before we read any more about this, I kind of prematurely took us there. Let's go back real quick to the image so I can explain something. Now, if the transformer was out here, and it's a utility transformer, okay, you see my mouse on the screen. If the transformer was out here on a pole, and it dropped from the pole to right here, then this would be under the exclusive control of the utility. So based on 90.2 of the NEC, that is outside of the scope of the NEC. And if it's outside of the scope of the NEC, then 230.24 can't apply. However, let's say this property had a transformer that was 50 feet away, and the utility said, we're going to stop at this transformer. Yet it's too far for the service drop to go over to the actual building, so they have to put another pole in. Now, if they stop at the transformer, that is now the service point. And the drop from that transformer now to the pole, and then continuation from that pole to the side of this building, might be installed by the electrician. And if that's the case, that is called an overhead service conductors. And that is indeed governed by the National Electrical Code. In fact, that is what we're talking about here in 230.24. So I think it's an important distinction that most people won't argue anyway. They'll say, well, I'm just going to make sure that I put the point of attachment high enough that I'm going to meet 230.24, even if it's service drops, because they don't want the headache and the inspector who may or may not know the difference in 90.2 and whether this is covered or not. But also they're charged with something that if it's too low, then it's unsafe. And so they have to protect their what? The constituents of their community. They're public servants to the community. So at the end of the day, it becomes a compromise, and most people just follow 230.24. But I thought it was important for you to understand the language in the code to differentiate. Now, it's a great time for you to pause and go look at 90.2 and see what's covered and what is not covered in the NEC. But as you expected, we will cover that in other videos. Can't cover everything in one video. People have told me my videos are too long, so we're trying to break them down, okay? All right, so let's go back to the code real quick. So here we are, and we're going to be looking at B. So here it is. Notice it also says vertical clearance of what? Overhead service conductors, not service drops. And that's a defined term in Article 100. So now let's assuming this is an overhead service conductor. Then you have the clearances right here. And we chose, in this case, it was 18 feet right here, 18 feet. Why? Because this looks like a commercial building and it's a non-residential driveway. So 8 inches for public streets, alleys, roads, parking areas subject to truck traffic, driveways, and other than residential properties and other lands such as cultivated, grazing, forest, and orchard. Okay? So It is subject to truck traffic, driveways that are other than residential. So obviously it's not a residential driveway like you'd have at your house or whatnot like that. So in this case, 18 inches of clearance, if those were overhead service conductors, is required. And you're just going to adjust your point of attachment on the side of that building in accordance with that, okay? So, to get your clearance, if these were overhead service conductors, then obviously to get your clearance, you might move this point of attachment in the weatherhead higher in order to be able to facilitate that. Make sense? Okay. So that's clearances. So I do want to remind you folks that take the time to go look at 230.24 and get used to those different clearances, because that is low-hanging fruit on an exam, right? And now you know where the clearances are if they're overhead service conductors, okay? Let's kind of go down a little bit and see what else we, okay, we covered the note and we looked at all that, okay. So again, as I told you, we're going to cover one more in here. So again, this is going to be a little longer than normal, of the normal norm that I'm starting here. Vertical clearance above platforms. All right, so look at what we've got here. So here you got to stay 3 feet away, right? We just saw that in the previous requirement, and so we had to stay at least 3 feet away, right? So let's look at this right here. So the drip loops. A drip loop's lowest point has a minimum vertical clearance of 10 feet. Okay, that's in 230.24b1. Okay, that's when we can go back and look at that just real quick because we do see chevrons. Here you go. Here's that vertical clearance. Again, overhead service conductors. Here's B1 right here. There's the 10 feet. And so this is at electrical service entrance to buildings, also at the lowest point of the drip loop of a building's electrical entrance, and above areas of sidewalks and above areas or sidewalks accessible only to pedestrians, measured from the final grade or other accessible surface, okay? If you have a rooftop and it's accessible, then you still have drip loops. You're still going to have to maintain that clearance. So that's kind of one of those things you got to be aware of. The conductors might have to be at least 8 feet, but then if it's an accessible rooftop, then you got to worry about that 10-foot clearance to the drip loop. That might cause those conductors to have to move up higher. See how the code works? So many things get intertwined here, all right? And it says surface only for overhead service conductors supported on or cabled together with a grounded bare messenger where the voltage does not exceed 150 volts to ground. Okay, so that's a 122/40 drop. Any one of the phases to ground is going to be 120. So again, it does not exceed 150 to ground. Okay, so we have to have that 10-foot clearance. Okay, also I will tell you this applies also around your houses to that service, the drip loops. You need to have a minimum of 10-foot clearance. Okay, so again, low-hanging fruit on an exam, folks. 10-foot clearance. Okay. All right, let's come back to the illustration here. So that's where we got that 10 foot. So right here, it's 3 foot out, and obviously we have 10-foot clearance, and it's measured from this point where they can stand on the platform, right? You notice what it said in the code? It said what? It said lowest point of the drip loop in the building's electrical entrance, I'm reading here, and above areas or sidewalks accessible only to pedestrians, okay? So again, being able to reach those from the platform, you make sure that you have to have that clearance, right? So in this case, minimum of 10 feet. And notice it says final grade or other accessible surfaces, okay? Now, going down a little bit, we're going to look at, here's the conductors right here. So they kind of drop over, right? All right, so vertical clearances, the final span above or within 3 feet measured horizontally of platforms. You saw that earlier, platforms, windows, doors, or whatever, okay? It says the vertical clearance and the final span above or within 3 feet measured horizontally of platforms, projections, or surfaces that will permit personal contact must be maintained in accordance with 230.24b. And we saw that. So this platform, I have to have the clearance above it, right? But I also have to make sure that these conductors stay 3 feet away from it. right? So all of that, here's a door, gets to be 3 feet away from the door. Here's a window. We'll assume this is an openable window. Okay, stay 3 feet away from it. Of course, this is over the window, so that's not an issue. Okay, so we still have all these clearances that we have to be aware of. Okay. And then D, right here, here's the window. It says here, the 3-foot clearance required does not apply to the conductors run above the top of the window. We saw that. Okay, that was in the exception. If the window, it doesn't have to apply to the top of the window. Because the fire escape platform, because it is a platform, people stand on it, is accessible to pedestrians. The 10-foot vertical clearance takes precedent over the window clearance. Okay, so just because the window doesn't come into play above it, it still needs to be high enough because the platform is accessible to pedestrians. They can get there. So we still have to have the 10-foot clearance above it. Okay, see how all that works together? You have to be very aware of your situation, right? And if none of this was here, then these conductors would only have to be what? 10 feet from grade. But because of these platforms and people standing out here on it, it could be accessible. So it has to be 10 feet above. Make sense? All right. Let's see here. That's it. And I think that is probably all. Absolutely. That is all we're going to cover in this episode. As we get into another episode, we're going to get into panel boards and equipment and obviously access to overcurrent devices. All those things we're going to get into. So much to cover. We're just touching the tip of the iceberg. So much of the material is still below the water, and you're going to learn it all in our Fast Trax program. So if you're interested in getting into a good code-based course, the Fast Trax system is the only way to go. It's the only way to go. And you get so much information. You can print out any page you want from the course material, anything you want to print out, charts, guides, whatever. We do calculations. You're going to be so familiar with calculations when you're done here. Again, they still can be challenging, but you're going to have the basic foundation on how to solve these questions. And that's going to help you in the real world, not just on an exam. And that's what the program's all about. So if you're interested in it, check it out. If you have any questions, as always, let us know. We have a contact us button right there on our website at fasttracksystem.com. We hope you get something out of these episodes. Quick, trying to keep them concise, not too long. This is longer than normal that we're going to be doing, but hopefully you get the information. Thanks again, folks. God bless. Until next time, stay safe. Take care. Hey everybody, welcome back to Electrical Code Academy. My name is Paul Abernathy. I'm your instructor. And today we're going to talk about service conductors in this episode. Talk a little bit about them, see some illustrations, kind of give you a little better understanding. All of this comes from our Fast Trax system. So if you're studying for an electrical exam or you just want to become better at the National Electrical Code, I can promise you something. I've been doing this for over 30 some years. All you got to do is go to the front of the code book and you will see my name under Code Panel 5 and Code Panel 17. So I'm not new at this game. But what I do that many educators don't is I try to make it easier for you to understand the National Electrical Code because it can be a daunting topic to talk about the National Electrical Code. So I try to break it down and make it a little easier for you. If you want to get in a good structured program to really learn the code, you'll be tested on your skills. It's not easy, but you will learn a lot from it. It's right here. All you got to do is go to fasttracksystem.com. We have demonstration videos on all of our courses. And you can go and learn more about it. If you want to get into exam prep, then that's the Fast Trax Black or even the Plus. What's the plus? Well, the plus gives you also a year access to fasttrackstube.com. And that's where videos like this will be held exclusively for you to learn from. So that's just a discounted access to our Fast Trax tube. If you want to learn residential post licensing, we have our residential courses, commercial courses, grounding and bonding courses. Probably one of the most important courses you should take is grounding and bonding. We have all of those, as well as some very advanced courses like Magenta. That is a seriously advanced course. All those things are available over on fasttracksystem.com. Okay, enough of the commercial. Let's get into today's episode. We're going to be talking about service conductors. I'm going to try to give you some good information on service conductors. Obviously, we're not going to cover everything, but that's kind of a snapshot of what our course provides. And hopefully you'll jump into the course, but hopefully you enjoy this video. All right, so let's go on and get into it. All right, on this episode, again, obviously we're going to talk about service conductors. And for those that are following along that happen to be in our Fast Trax program, it's 10-2H, and that's where we're going to be, right? All right, so let's kind of look at the material here. And as always, we have some great illustrations, and we have good call-outs because we really want to be able to point to the things that we're talking about. So service conductors, let's talk about A. So A right here, okay, is right here. We're talking right here. And we're going to look at A. So if service conductors are supplying power to more than one unit in a multifamily dwelling, okay, so in this case, we're talking service conductors, and we're going to try to stick on the topic today like multifamily. Because the reason I like to do this is because when we're talking about things like one-family dwellings, most people are pretty aware of those nuances, right? You have a service drop, comes down to the point of attachment, right? And you have that service point where the utility leaves off, and the National Electrical Safety Code should say for the utility, and the NEC begins, right, on the load side of that service point. So we're pretty much familiar with that. You have service entrance conductors that come down into the meter and then go into the emergency disconnect or your service disconnect. Could be both. That's 230.85. We're familiar with that. So to illustrate a little more higher level topic for service conductors, I'm going to talk about it from a multi-family dwelling aspect to kind of ramp it up a little bit, because I think the other than the component stuff, which we will get into, like terminating in a service and the grounding electro system, we will get into that in these series. But I think we want to keep it where it gets complicated for people, especially when we're talking service conductors, because the other stuff is pretty simple. Here's where it can get complicated for people. So that's why we were going to kind of jump into this topic. But it's still going to be germane, so don't wander. It's all good. So A here says, if the service entrance conductors are supplying power to more than one unit in a multifamily building, using 310.12 and table 310.12 is not permitted. Okay? All right, so if the service conductors are coming down, these conductors here are coming down, this like the service drop or whatever it might be are coming down, then if it's supplying power to one building and everything was being supplied by that one set of service entrance conductors, then guess what? If that was the case, then I would be able to use 310.12 and table 310.12. Now, if you're not familiar with table 310.12, that is the 83% rule that you hear so many people talk about. And I encourage you to pause and go watch that, because that's going to be done in a separate video where I explain that and understanding the nuances of 310.12. But in this video, I just want you to know that you can't use that. And so the reason we get that out of the way up front is because these service conductors aren't supplying the entire load of the building, right? So if you look at this illustration, these conductors that are in here are supplying only these loads. It's not supplying the whole building. So it doesn't have the luxury of using the 83% rule. Okay? So I know that's some people that's going to be confusing. Paul, then go ahead and explain the 83% rule in 310.12. I'm not going to do that because we're going to save that for a different video. I just want you to know that it's not going to apply here. Why? Because these service conductors right here, coming from the service drop connected, these service conductors are not seeing the entire load of the entire building. They're only seeing the load associated with these 6 units. Okay? So therefore, 310.12 can't be applicable here. Right? Also, since this is supplying 6, it's also not supplying a one-family dwelling or an individual dwelling unit. So that's also something that 310.12 tells you, that unless you're doing that, then you can't use the 83% rule. So what does that mean? Well, that means you have to size the conductors using the normal ampacity tables in 310.16. Okay? You don't get to use the 83% rule. You just size them like you normally would, use the ampacity values from the normal ampacity table 310.16. Hopefully I made that clear for you. All right, now it says is not permitted. It says now, in accordance with 310.12a, selecting conductors from table 310.12 shall be permitted where the service conductors supply the entire loads associated with an individual dwelling unit in a two-family or multifamily, or supplies the entire load for a one-family dwelling. Okay, but we're not talking that today because that's obvious. Here we're trying to make it a little more complicated. All right, so in this case, it does not. So you can't apply 310.12. So the reason we do this is get that out of the way. You cannot use the 83% rule on a setup like this where you have potentially multiple services like this. And again, each one of these obviously has a breaker on it. Okay. And this is one service to a building, one drop. Okay. So you can't use 310.12, but you're going to do a load calculation and you're going to size those conductors based on your load, right? That's what you're going to do. And that's traditionally what you would do anyway. So that's why we kind of get that 83% rule out of the way. In a multifamily like this, you're not going to be able to do that. Now, you could do it to the individual dwelling units, right? That would be a feeder. And if you do the feeder to the individual dwelling units, then you could use 310.12b for that application, right? And again, we're going to cover all that in a unit that we really dig deep into 310.12. All right. Now, in our course, multifamily using the standard method of calculation and the optional method is covered in Unit 11. So anybody that's checking that out or looking into our course, Unit 11 will go into all of those things. You're going to do a calculation for a 6-unit complex and also a 12-unit complex. Okay. So don't worry, our course is going to cover all of that material for you. All right, let's kind of work this thing out real quick. Since we can't use 310.12, let's kind of look at what we've got here. So C, which is pointing here, it's kind of just for reference, going to use the other one. It says, now, if the calculated load, that means you did the math, you calculated it up, you used a worksheet, you came up with it, you used either part 3 of Article 220 using the standard method, or you used the optional method in part 4, however you did it, you came up with a calculation. So if the calculated load for each service disconnect is 350 amps, okay, so that's what we calculated out. And then, of course, with that, that's what we determined the size of the service disconnect, right? We did a load calc, whatever it was, and that's how we sized our service disconnect. Okay, makes sense. Now, it says the conductors shall have an ampacity of at least 350 amperes. Okay, now, in accordance with table 310.16, you heard me talk about that before, ampacity table. Again, we can't use 310.12. This wouldn't apply. So we're going to use the full ampacities from the table. In accordance with 310.16, the minimum size conductor is a 500 kcmil copper or a 700 kcmil aluminum. Now, a 500 kcmil copper, on an exam, y'all all know by now, you always assume copper unless stated otherwise. They ask you for aluminum, then you use the aluminum. But if they don't state aluminum, again, always use copper. In this case, a 500 kcmil copper under the 75-degree terminals, which is probably what everything's going to be rated at, then what you've got is 380 amperes. Well, obviously, 380 ampere conductor can easily handle 350 amps of calculated load, and the overcurrent protected device is more than capable of protecting a conductor that's good for 380 amps. That's not a problem. D, right here, it says, 2 main service disconnecting means supplying power to 12 units must be computed on the basis of 6 units per service, right? Obviously, again, this is 6 here, this is 6 over here, okay? And it's a 12 unit total complex. All right, we got that. Performing a service calculation on 12 units and then dividing that by 2 is simply incorrect. Okay, so you're going to do the calculation what? Based on 6 at a time because they're separated out. So you're doing 6 and then you're doing the calculation for 6 over here for these conductor sizing. All right. Now, all service supplying dwelling units, okay, the dwelling units shall be provided with a surge protective device, SPD. The SPD shall be an integral part of the service equipment or shall be located immediately adjacent thereto, unless it is located at each next level distribution equipment downstream towards the load. Okay, so the SPD shall be a type 1 or a type 2. And also, if there's a retro or remodel and you replace the service, then you have to install SPDs. Now it's a requirement. Right? So in this case, you can put it at the service, or you can put it at the next downstream distribution, which would be at each one of these feeder panels, if you wanted to do it that way. And it'd be type 1 or type 2. Now, type 1 typically is on the supply side of the service disconnect, and type 2 is typically on the load side, but check with your manufacturer because I believe manufacturers make some type 1s that can go on the supply side or the load side. But they typically will be used on the supply side, and typically type 2 will be on the load side. Of course, if you want to learn more about the SPDs and all the things associated with that, then here, all you do is go to 230.67, and you notice that we put that in chevrons right here. And so for anybody that's new to the course, anytime you see a chevron, you're going to go there. You're definitely going to go to wherever in the code it tells you and read it. So we're going to do that right now so that you can kind of see what you would do if you're using the studying properly, the techniques properly. All right, so we're going to go to the code. And we're going to look at 230.67a. So I'm here. I'm in 230 already. So let's go to 67. Right here. All right, now see all this new? The formatting is new, and it's new for the 2020 edition of the National Electrical Code. That's what we're in. So, surge protected devices. It says all services supplying dwelling units shall be provided with surge protected devices, SPD. Okay. And I don't think there's any illustration. No. Okay. Location. Where can these SPDs be? All right. As you saw in our language here, it says SPD shall be an integral part of the service equipment, either right on the bus, a plug on the bus, or built into the equipment, whatever, or shall be located immediately adjacent thereto. So that means that some of the ones that you see for services, now this is not just for multifamily, right? This applies where? All services, okay? So some people will see the ones that mount right next to the panel. And then you got a, kind of a nipple over to it, and then the conductors go straight to a breaker. Manufacturer tells you to keep those conductors as short as possible. We don't want a bunch of loop-de-loops, okay? Keep it short as possible. But there is an exception here, as you can see, and the exception says, like we read, it says the SPD shall not be required to be located at the service equipment as required if B, I'm not sure what that is, if B, okay, so required in B, I'm sorry. So let me read that again. This SPD shall not be required to be located in the service equipment as required in B, which is what we just read, if located at each next level distribution equipment downstream towards the load. Okay, so you could have them at the actual dwelling units. How about that? And that would be fine. And it might be just a plug-in on the bus, that type of thing, keeping it simple, stupid, and that's probably the majority of how they're done today. Although some of the manufacturers make really nice ones that go immediately adjacent, and they have a little viewing screen, and they can be mounted recessed or surface mounted, however you want to do that. But again, today, a lot of people are just using the plug-on ones and getting it over with. They just take the place of 2 breakers and plugs right in. And of course, here you also see the types, and then of course, replacement. This is the important one here to remember, that where service equipment is replaced, all the requirements of this section shall apply. So if somebody is doing a service replacement and it wasn't there at the old service, it wasn't required at the time, obviously, because this is a 2020 code. But when you put that service back, guess what? they're now going to have to put in these surge protective devices. So if you have a big multifamily complex and they change the service or do some changes there, then it's going to affect the SPDs. So it may or may not be as simple as just going to each one of the dwelling units and doing a plug-in. It may not be that simple. So it can possibly get complicated in how this is to be applied, but code's pretty clear you're going to do it. Now, if you want to learn about the different types of SPDs, so you have overcurrent protection, right? And you have over voltage protection. And that's basically what SPDs are doing, the over voltage protection. So when you're looking at that, you're saying, okay, where do I go in the code for over voltage protection? Well, you're going to go back here. You see where it says 240 for overcurrent protection? We'll see under it now, there's a 242, and we'll just kind of look at it. And you'll notice the N right here. That means this is new for 2020. Now, not new in a sense they didn't exist. They did exist. Okay, they were other locations in the code, and they got relocated here under 242 because it seemed to make more sense to kind of put it next to overcurrent, and then of course then you have over voltage protection. So here's where you'll see the SPDs, right? Talking about SPDs right here, and you kind of can go down it, and a good table that kind of connects you with other locations and other articles that may be applicable. But if you go down here, you'll see surge protected devices for 1,000 volts or less. Okay, and you'll see listing and yada yada yada. And here it starts talking about the type 1s and at the service and the connections. And here's type 2s, gives you some information about those. Type 3s, type 4s, and locations. And so anything you want to learn about SPDs are going to be here in 242. And of course, you also have surge arresters, which are over 1,000 volts. That's also here as well. That was also in a different article, and it was relocated here to 242, right? So it's all conveniently located now in Article 242 if you want to learn the different types of SPDs and their applications and all that. But when it comes to services, the direct requirement to install SPDs comes from 230.67, okay? All right, let's go and get back to our material. All right, so that's all we're going to talk about in this episode, talking about the services, the service conductors, and hopefully you got something out of that. The next series that'll come up, we're going to be talking about conductor clearances over flat roofs, and we'll be talking about it maybe over pitched roofs and all those goodies involved in Unit 11 of our Fast Trax program. But I'm giving you a look by doing these videos to kind of give you an idea of what's in the program, and maybe you learn something from the material that I'm presenting. Again, if you want to get in a really good code-based program, you really want to think about coming to our Fast Trax program. Again, right here, you're going to learn so much about the National Electrical Codes. It's just going to open up your eyes. The illustrations are wonderful. You're going to wonder why we do what we do, and it's because we really are passionate about teaching you the code, not just helping you get past an exam, not just making you a better electrician in the field, but making you a supertrician, right? Every good electricians know how to wire, know how to pull things, know how to bend conduit, know a little bit about code, but great electricians know both, okay? They know how to install it, but they know the reason why they're installing it. And that's what our course is there, is to supplement that good electrician to become a great electrician and learn more about the National Electrical Code, which, again, has this relationship with the installation. Everything that you do, whether you admit it or not, is based on code. The skills you learn are to install things in a safe manner. The National Electrical Code is a minimum safety standard, whether you like it or not, whether you like that definition of it or not. So the more you learn about code, the better you're going to be, and that's why I'm here. So hopefully you got something out of this episode, and maybe you'll come back and join us for future episodes. Again, I promise to start keeping these videos short, and that's what I'm going to do. So folks, we'll catch you in the next video. Till next time, stay safe, and God bless. Hey everybody, welcome back to another episode of Electrical Code Academy. And my name is Paul Abernathy, and I'm your instructor for this episode. If you've never seen anything that we've done before at the Fast Trax program, you really need to look at our website and you need to watch the demo videos. I've been doing this for over 32 years. If you want to know who I am, Google me for a second, or you can go to the front of the National Electrical Code and see that I'm also listed in Code Panel 5 and Code Panel 17. Now, I don't say that to brag. The reason I say that is when you're trying to learn the National Electrical Code, you want to learn from trusted sources. There's a lot of people out there that teach the National Electrical Code, but do they have the pedigree? Do they have the background? Can they convey things to you in a way that's easy to understand? And that's what I strive to do. I've spent my entire career doing that. And I've had literally over 50,000 students in my career since 1989. So I started actually back in 86 in my programs at the vocational school, and I went on to own my own electrical contracting businesses multiple times. And I've been an electrical inspector, electrical engineer for a large municipality, code supervisor for a large municipality, and I've also been one of the NEMA rep regional experts for the National Electrical Manufacturers Association until I also head up a codes and standards division for one of the leading manufacturers of wire and cable in the country. So I've had my hands in a little bit of everything, but the one thing that I'm most proudest of is being a master electrician in multiple states and working my way with my hands up through. Way more prouder than anything I've done in engineering is being a master electrician means the most to me. So learning the National Electrical Code is something that everybody needs to add to their repertoire. Okay, you can be good with the hands, you can be good at bending conduit and all that, but do you really know why you're doing things, how to lay out circuits, what they mean? You do things off of repetition and you don't understand what's code and what's not. Our programs teach you the National Electrical Code. You'll be better at your job. You'll be a better leader. You'll have less stress because you're going to know how to work the NEC. And be honest with you, our course would teach you an awful lot. So you don't even have to be studying for an exam to be in our program. You just want a better understanding of the National Electrical Code, just to make your job less stressful by knowing where to go in the code book or building up that memory of code knowledge. Okay. Now, if you want information on our programs, right there, go to fasttracksystem.com. If you're studying for an electrical exam, Fast Trax Black is the one you want. It works in every state. Okay. We just teach the NEC. I don't teach OSHA. I don't teach the local regulations in your state. I only teach the NEC. That's the portion that people tend to struggle with. You can get pamphlets on local rules and regulations and OSHA. Very simple. But the code is what stumbles people, whether it's the calculations or the code lookup. So I'm the one that's going to be able to help you with that. You can, if you're already licensed and you want to deep dive into residential, we have residential program, that's the Fast Trax Red. We have the green program, which is commercial electrical wiring. We've got the blue, which is industrial. We have a grounding and bonding course that is probably the best course out there. You get access to these for an entire year, 24/7. There is no better course than our Fast Trax series, and we've got something for everybody, even electrical theory. We've got that as well. We even added a new course for electricians who work with HVAC systems. All the electrical troubleshooting, how to deal with certain situations that you may encounter. We have a course on that as well. So again, go to our website. If there is a demo, watch the demo and you'll learn more about our products. Okay, you're saying, Paul, you're just selling me. You're just giving me a commercial. Well, that's what I have to do. Now let's get into the course material. Okay, so what are we going to learn today? Well, in a previous episode, we talked about the receptacle spacing and how you would do the spacing out in general purpose applications like in living rooms, bedrooms. We did the 6-foot, 12-foot rule, but we didn't talk about kitchens, dining rooms, and like breakfast rooms. And so we broke that out into this episode. So we're going to talk about all things to do with kitchen, dining rooms, and breakfast rooms. We're also going to cover receptacle placements, but we're going to get into all those topics here in this episode. So let's go on and get into it, and let's get started. All right, so here we go, folks. If you're in our Fast Trax program, this looks awful familiar. We're in Unit 7. And this is 7-1, dealing with kitchens, dining rooms, and breakfast rooms. And we're talking about receptacles and the branch circuit ratings for the receptacles. So this is what the topic is about. And this is just building onto a previous episode, again, where we talked about normal receptacle placements and spacing and things like that. All right, let's get into it here. Receptacle placement in a kitchen is determined by 210.52a and c. So let me kind of clarify this. So in a previous episode, we talked about 210.52a. That's the 6-foot, 12-foot rule, right? Going around the room and a break in the floor line along the wall is where you start your measurements. Go 6 feet from that break, and then you could go a maximum of 12 feet to the next receptacle. If you don't know what I'm talking about, please pause. Go back and watch that episode and then watch this episode, because that's the spacing. Because in a kitchen, you still got your wall spacing. We're talking about the countertop. That's different. You still got your wall spacing that you have to do, and that's the 6-foot, 12-foot. And that's what we mean by 210.52a. You still got to have that wall spacing receptacles. Still got to have them. Now, the C, which is 210.52c, is very specific to the countertop in a kitchen. Okay, so you have the wall space requirement, and then you have the countertop wall space requirement. And of course, you'll have islands and peninsular requirements as well for those receptacle placements. Okay. Now, all of the general receptacle placement provisions are found in 210.52a. They're going to apply. Like I said, you still got to have them around the wall normally, as well as the additional requirements that are in 210.52c. And again, that's talking about the various countertops. So both of these rules are going to apply. So if anybody ever asks you what are the spacing and placement requirements in kitchens, well, 210.52a for the wall space around the wall, and then 210.52c for the countertop wall space, as well as islands and peninsulars and things like that. So got to meet all those rules. So wanted to make sure that you're aware of all of that. All right, so now you probably come to be familiar with our illustrations, some of the best illustrations in the industry. So here's your countertop. Okay, we're going to talk about that here in a second. So A right here, these receptacles, says receptacles installed on a 20 amp small appliance branch circuit may be rated either 15 or 20 amperes. Okay, and that's covered in table 210.21b3. Now, we covered this in another video, so hopefully you're subscribed and watching all of my videos, because in this video, we talked about receptacles, and you can go watch that at Fast Trax Tube, and it basically tells me that if it's a 20 amp branch circuit, then I can have a 15 or a 20 amp rated receptacle on that 20 amp small appliance branch circuit, right? So I've got a duplex, and that duplex can be either 15 or 20. Okay, and that can be serving that countertop. Now remember, as always, how many small appliance branch circuits do you have to have as a minimum in your dwelling? You have to have at least 2. Okay, at least 2. And where do you get that? 210.11c. Let's go to talk about it. You have C1, C2, C3. So for kitchens, you're going to have the small appliance, you're going to have the bathroom, you're going to have a laundry one, and then you're going to have a garage requirement for branch circuits. Okay, but you have to have at least 2 for the small appliance, and they have to serve the countertop, okay, the countertop locations. Now, all receptacles installed to serve the kitchen countertop surface shall have GFCI protection. That is in 210.8a6, talking about the countertops, okay? Now, if you were to pause right now, when you see these chevrons, as always, you're going to pause, and you're going to go look at that code section. But you're going to see other requirements in there. For example, any receptacles within 6 feet of a sink as well. But when it comes to countertops, all of those receptacles that serve a countertop have to be GFCI protected. Okay, and that's all in accordance with 210.8a6. That one specifically is for the countertop requirement. Now, we do have videos that are talking about GFCI requirements in 210.8. So again, you get a chance. Again, make sure you subscribe, share with everybody in your company, so that everybody can be on the same page. And if you want to get into a great program, folks, right there, fasttracksystem.com, we get deep into all this information. Then you can also come in Wednesday nights and bring any scenario you may have to me personally, and we can all learn together. That's the kind of what we're doing here in this community. That's what the fast track system's all about. All right, so let's go to B. So that was A. So here's B. Here's a little appliance here. It's a toaster oven. It says the maximum distance to any receptacle measured horizontally along the wall line is 24 inches. And where do we get that? 210.52C1. Make sure you go look that up. That's in chevrons. All right, pause the video. We tell the students to do this all the time. When you see chevrons, pause it. Go read the code. Now, some people ask me, Paul, how do I know what to highlight in my code book? That's fair, because there's so much stuff in this document here. How do you know what to highlight? Because if you end up highlighting everything, then it kind of defeats the purpose. So one of the advice that I give folks is to highlight things that we call out. So anytime you see a chevron, go highlight it. But only highlight the portion that is significant, okay? But anytime you see those chevrons, that's a good thing that you should highlight. And only highlight the significant portions of the code reference, right? That way you don't get everything highlighted and it kind of defeats the purpose. All right, now let's look at it this way. So the easy way to understand this is countertop receptacle placement is to imagine that you had a toaster with 24-inch cord. Anywhere this toaster is placed around this countertop, there should be a receptacle within reach. So what does it say in the code? 210.52C1. It has to be within 2 feet of the edge of the sink. This kind of breaks the countertop. So I have to have one within 2 feet of that. So there it is right there. Could it be at 1 foot? Yes. But the maximum is 2 feet. So this one, max 2 feet. So anything put here would be able to reach it. Anything put here would be able to reach it. And then the maximum distance between the receptacles would be 4 feet. Because if I put this toaster right here in the middle, it's going to be able to reach this receptacle or this receptacle. If I move it closer to this side of that 4 feet, then it can't reach this one, but it most certainly can reach this one. So that's why we have something called the 2 foot, 4 foot rule. Okay. Now let's look at some notes here. It says, in kitchens, pantries, break rooms, dining rooms, and similar areas of a dwelling unit, circuits that serve the countertop surface receptacles and general purpose receptacles shall be 20 amperes small appliance branch circuits. So that is 210.52B1. All right, let me make sure everybody's clear. The same small appliance branch circuit that serves these receptacles on the counter are also going to serve the receptacles around your kitchen, around the room. Okay, so if you have a minimum of 2 small appliance branch circuits per code, can you have more than 2? Absolutely. You can have 3, 4, 5, whatever you want. But those small appliance branch circuits are going to serve not only the countertop receptacles, but also the wall receptacles all around your kitchen, okay, and your pantry and in your dining room. All of those are served by those small appliance branch circuits. Now, I could have 2 for the kitchen and a third one doing the dining room. And all that would be fine. I can have more than 2, but I have to have at least 2. Okay. Note, receptacle outlets are only required to be installed behind a range, counter-mounted cooking unit, or sink if the area behind the range, counter-mounted cooking unit, or sink is 12 inches or greater. Okay. When installed parallel to an adjoining wall, or 18 inches or greater if installed in a corner. Okay, so that's under the exception. So we're going to look at the code for this. Why? Because a code has great illustrations to hammer this note home. So let's go to the code book. That's where you see this. When we see these chevrons, where are we going to go? We're going to go to the code. So let's do it. All right, so we're over here in the code. Let's go to 210.52. And here is where we start getting down, and here is what we're talking about right here, folks. So this could be a sink, this could be a cooktop, or whatever. So this space behind it is what it's talking about. If this is like a extended or extension face kind of in the counter sticks out a little bit, and maybe the cooktop or the range sticks out, what about the space behind it? Because as you saw in the other picture, the measurement comes from the edge of the sink. 2 feet, right? But what about this space behind it? Well, the space except space exempt from wall line if it's what? It's less than 12 inches. Okay? So if this space right here is less than 12 inches, then guess what? It's considered a break in the counter, and you're simply going to draw a line from the edge of the sink, the cooktop, whatever it is, draw it back, and that's where your line starts, and you have to have a receptacle within 24 inches. Right? There you go. And we'll read the code language too. Don't worry, we'll read the code language. Now, what about this one? So this is the one that's talking about with the corner. So in this one right here, if this is a sink, a cooking unit, or range, or whatever it is built in, then the measurement behind it to the corner here, this space is exempt from being considered wall space. All of this is exempt if it is less than 18 inches. So if this space right here is less than 18 inches, then I can forget it even exists. Okay? Now, reading this code language, okay, so this is the space, so we want to make sure that you read all of this code language. Here it is right here. Okay? It says, in kitchens, pantries, breakfast rooms, dining rooms, and similar areas of dwelling units, receptacle outlets for countertops and workspaces that are 12 inches or wider. Oh, that's not the one we want. I'm sorry. That is not the one we want. We want the reference. It's just the figure. Okay, kind of looked at the wrong reference here. So we have to look at the figure. That's what this one is. It's all about the figure. Okay, so right here again, we'll look at it. This space right here. I don't know what I was like. So, oh, by the way, since we're here, this one right here for the 12 inches, that means on the countertop, if you have like an efficiency apartment and you have a small countertop, if it's at least 12 inches wide, then a receptacle has to be there. That's what it's saying. If it's only 6 inches wide, then you don't have to have a receptacle there. That's what that means. Okay, so every countertop or workspace that's at least 12 inches has to have a receptacle. It's an interesting question. People say to me, Paul, what if you're wiring, and we'll get back to the counters and the sink and the cooktop and all that. We'll get that in a second. But let me tell you, some people say, Paul, what if it's an efficiency apartment and I have a counter and it has maybe a cooktop in it or a range in it, and maybe the counter beside it is 18 inches. Would I require a receptacle there? Because remember it says within 20 feet, you can go up to 24 inches. But this counter is only 18 inches. Do I have to have a receptacle there? And the answer is yes. Based on what? Based on this right here. 12 inches or wider shall be installed in accordance with 210.52C1 through C3. Means I've got to have a receptacle there. Now, somebody says, well, Paul, what if that's my only counter? And I have to have, by the code, a minimum of 2 small appliance brand circuits there. Would I put 2 duplexes there, and one is one circuit and one's the other? Or could I put a duplex receptacle there, break the tab on it, and then the top be one brand circuit and the bottom be the other 20 amp brand circuit, small appliance brand circuit? And the answer to that is absolutely. You could do that if you wanted to do that. Or you might put in a quad in there, and you have 4 receptacles, 2 duplexes mounted in a 2-gang box. And then one receptacle is one circuit, and the other receptacle is the other circuit. Still have to have at least 2 small appliance brand circuits there, okay? And of course, they can actually split out and also catch all the other receptacles in the kitchen as well also. But as far as serving the countertop, that would be fine. But if the counter is at least 12 inches or greater, then I have to have a receptacle to serve that countertop. That's what that was there. That wasn't reading. So let's go back real quick. And we saw the illustration. And so this is your counter in your kitchen. And you have a sink. Let's just call this a sink for simplicity's sake. And here's a sink in the corner one here, corner mounted one here. Okay. All right. And so in this case, again, this space behind it, if X is less than 12 inches, ignore it. And the measurement starts here. Imaginary line comes back and you measure this way. And you have to have one within 2 feet of this imaginary line, which connects back to the wall. Perfectly fine. You don't have to count the space. Down here, same thing. If this space and a corner mounted one, if between here and the corner is less than 18 inches, then you can ignore this space. And the measurement starts by drawing an imaginary line. Let me bring this up here so you can see it. An imaginary line right here. See my mouse? Right here, draw a line back to the wall, and this is where your measurement starts, right from that contact point this way. Same on this side, measurement starts this way, okay? So bringing us back to our course material, that's what it says right here, right? So our sink behind our range or cooking countermounting unit or sink is 12 inches or greater, okay? Where installed parallel, again, if it's 12 inches or greater, then guess what? I have to put it's just part of the wall space. So I have to count it, and I might get a receptacle back there, okay? Still got to do the 2 foot, 4 foot. If it is less than 12 inches, ignore it. And same with the corner mounted one, right? Down here. If it's 18 inches or greater, then a receptacle has to be installed. If it is less than 18 inches, forget about it. You don't have to have a receptacle back there. You don't start your measurement except for at the corner of the sink or cooktop or range or whatever it is. Pretty simple, right? So this is just over at the code. This is just an illustration, right? I'll be honest with you. I don't see too many of these. Usually the sink is actually in the counter, so it would that space behind it's only like 2 or 3 or 4 inches anyway, like we see up here in the picture. Let's go back to the picture right here. This is typically what we see, right? So this space behind here is basically a break in this wall line. And so your measurement starts from the edge this way and the edge this way, okay? That's typically what we see, right? But I just want you to know that there are illustrations in the code book in case you get confused about that. Okay, other outlets fed from the small appliance branch circuits. So we've been talking about the small appliance branch circuit. So what else could be on that small appliance branch circuit? So we pretty much covered spacing. But in order to kind of get this video up a little bit, we're going to kind of go into what other things can be on that small appliance branch circuit. Okay, we know how to space it now, 2 foot, 4 foot rule. We know that that same small appliance branch circuit has to also pick up the other receptacles that are in the actual kitchen, pantry, dining room. And can we have more than 2? Absolutely. So we could have 2 that stay in the kitchen and the third one picks up the dining room or the pantry. That's fine. Not a problem. But you have to have at least 2. But let's talk about what else can actually be on that small appliance branch circuit. Okay. All right. So here we see a nice illustration. It kind of lays out what can be in a kitchen. And this is, again, a lot of people ask questions about this. So A is right here. So this is called a clock outlet. Typically, we don't see these today. Back in the day, it was actually a recessed outlet with the actual receptacle recessed back. And so it actually would, the clock would plug into it. It would sit flush on the wall. Okay. Well, if that's the case, there is an exception to 210.52b2 on what can be on these small appliance branch circuits. Well, I can have a dedicated clock outlet if I want. Again, I don't see them anymore, but I could put that on there. It's not really going to pull anything. It has no real significance to the load, but that's okay under exception number 1. That's not a problem. Now, what about next? Let's see. This is a hood fan. So you might have a range here and you've got a hood fan there and your exhaust fan. And you're thinking, hey, can that be on this small appliance branch circuit? Okay. A hood fan is not permitted on a small appliance branch circuit. 210.52b2 gives us that direction and says it cannot be on a small appliance branch circuit. Also, just because we're talking about it, a microwave could not be on the small appliance branch circuit. Okay? The manufacturers of that microwave are going to have in their instructions to run a dedicated or individual branch circuit to that microwave. Well, you have to follow their instructions. Okay? But also looking at the load that it draws, and it's typically cord and plug, then you have to be careful because we're going to have to limit things to like 80% of the rating. So just know that the microwave cannot be on the small appliance branch circuit. All right, next, C. And look at this receptacle that's just outside. You're thinking, oh man, I have an outside receptacle. It's in that common wall. Nobody's looking. I'll just take my small appliance and drop it out there and hit that outside receptacle. Absolutely not. Outdoor receptacles are not permitted on the small appliance branch circuit. Where is that covered? 210.52b2. Do me a favor. Pause, go read it. Read what it says about it, and then come back. That's what we do in the Fast Trax program. So if you want to get the most out of this, you need to be moving in and out of your code book in order to get, don't be lazy on me. Okay, don't be lazy. Move in and out, in and out, in and out. Okay, so let's go to the code 210.52b2. And I will show you that to show you understand that that's what it says. 210.52. And we'll go down here to B2. No other outlets. Now, when we see no other outlets, folks, that means lighting, no other outlets, no lighting outlets, no other outlets outside, those type of things. No other outlets. So it says, and here are the exceptions that we've been talking about right here. It says, the two or more small appliance branch circuits specified in 210.52b1 shall have no other outlets. And again, don't get locked into thinking outlets means receptacles alone, because it does not. I know it's very common for us to look around a room and go, oh, look, there's an outlet, but that's true. That's an outlet box. But what you're pointing at that you put an attachment plug in, that's a device. Okay, so people refer to that as outlets all the time, but it's really a device. Okay, but we know what you're talking about, so nobody really gets all worked up about it, but I want you to learn the terminologies. It's going to make you a better electrician altogether, and it's significant because another outlet would be a lighting outlet inside of a kitchen. So I can't have the kitchen lighting on with the small appliance branch circuit because that would be an outlet, and I can't have any other outlets on it. Now, here are the exceptions. The first one right here that we just looked at, that's the one for the clock. That's okay to be on the small appliance branch circuit. The next one is exception number 2. It says, receptacles installed to provide power to supplemental equipment and lighting on gas-fired ranges, ovens, and counter-mounted cooking units. That's okay. So what does that mean? Well, maybe I have a gas range. Maybe I have a gas cooktop. And all I'm trying to do is supply a receptacle for the igniter, right? Well, if that's the case, and in a lot of homes with gas cooking, you'll have a receptacle down there to plug in the igniter, electric igniter. Can that be on the small appliance branch circuit? Absolutely. Based on what? Exception number 2. Those are the only 2 occasions where you can have other things on that small appliance branch circuit. Can't have microwaves, can't have hoods, hood fans, none of that type of things can be on them, okay? That's very important for you to realize. All right, so let's come back here. Also, make it really clear that, just because maybe this is a counter and it overlooks a living room, these receptacles on this side of this dividing wall are serving the living room. Okay, they cannot be on the small appliance branch circuit if they're on the side and this wall is designated for the living room. It's serving that space, then no, sir. It cannot be on the small appliance branch circuit. Important to realize all that. So it's very specific for what can and cannot be on that small appliance branch circuit. Now here, just so you see things like, D says the lighting outlet is not permitted on the small appliance branch circuit. We looked at that. And then E says, circuits feeding receptacles in kitchens, pantries, breakfast rooms, dining rooms, and similar areas shall not feed receptacles outside of those areas. That's what those small appliance branch circuits are for. They're certainly not for feeding the living room. Okay? All that makes sense. Note, a 120 volt receptacle installed for, and it actually should be a 125 volt because that's a a NEMA rating for the receptacle, but it is a 120 volt branch circuit, so we'll let it go here since it is kind of talking about the small appliance branch circuit. But it says a 120 volt receptacle installed for a gas cooking equipment can be fed from a small appliance branch circuit. And again, that's what we saw, exception number 2. And that again, folks, is why it's so important to stop and go look it up. I can't overemphasize that. That is how our program works. And if you're not going to work the program, really do me a favor, don't waste your money. I want to help you. But don't think buying our course that you'll just be able to learn this by just osmosis. You got to put in the effort. You got to follow the plan. Just give me that time. Give me that effort, and you will learn the NEC. I've committed my life to this, and you will learn it. All right? So we talked about the countertop spacing, and so we're going to look at it even more. We're getting even deeper with this episode. So we kind of touched on it, but now we're going to put all of that we learned into practice. Ready? All right, kitchen countertop placement. All receptacles installed to serve the kitchen countertop surface shall be GFCI protected. That is 210.8A6. Remember, go look that up. It's in chevrons. The branch circuit in a kitchen shall be 20 ampere circuits. Again, that's in 210.11C1 and 210.52B1, saying that they have to be 20 amp branch circuits, and you have to have a minimum of what? At least 2. So it says right here, a minimum of 2 small appliance branch circuits are required for receptacles serving kitchen countertops. It also reiterates that in 210.52B3 as well. Now it says either or both of these small appliance branch circuits may feed other receptacles in the kitchen, pantry, breakfast room, and dining room. Of course they can. So you could have both of those. Say on your countertop, half of your countertop is one small appliance branch circuit, then it goes out and does the wall receptacles, and then the other one goes out and goes and hits any receptacles you might have in a pantry, and then comes out and maybe picks up the receptacles in the nook area, because that's a similar area to like a dining area. So it could pick up all of those. That's fine. But can you have more than 2? Absolutely. If you want to have a third small appliance, go for it. A fourth one, go for it. No problem with that. Just make sure when you do a load calculation that you account for 1500 VA for every small appliance branch circuit. But don't worry, we talk about that when we do load calculations for single family dwellings. Again, if you haven't watched that video, please make sure you subscribe to the channel. It is available. And if you want to see it right now, go over to fasttrackstube.com and subscribe. It's $125 annually. That helps support all this that we do. Again, so we thank you. It's a small amount to pay. I promise you, you'll get more out of it than the cost of it. But to make it even better for you, I'm going to give you a discount. If you check out on Fast Track's Tube, that's FASTTRAXTUBE.com, use the coupon code 25OFF. That's 25OFF, all caps. Then you'll get $25 off, and it'll only cost you $100. And again, it's a way to support our channel. And we're moving towards a subscription platform. And we're going to bring you more videos from not just me, from other educators, all in one location with a bunch of neat features that you would never find on YouTube. Promise you, it's going to be a great experience. And it works perfect on your mobile phone. All right? It's very adaptive. All right. So let's look here. Now, also, receptacles located more than 20 inches above the countertop or work surface are allowed, but they do not count in the required receptacle spacing. Remember we talked about this in a previous video, whereas if you had a receptacle that was above 5.5 feet around, let's say in a bedroom where you're putting a receptacle for, let's say, a flat screen TV, that receptacle, if it's above 5.5 feet, it can't count in your spacing of the room receptacles. Well, the same thing goes for this when you're doing countertop receptacles. If the receptacle's above 20 inches, it doesn't mean it can't be there, but it can't count as these small appliance branch circuits, okay? Also, the receptacles that are on the small appliance branch circuit, also, those receptacles that you put up high really should not be on the small appliance branch circuit if it's for something like the microwave or something else. So be very careful in your placement. if you're going to put the receptacles to serve the countertop, then you don't want them higher than 20 inches. Now, a lot of times people don't want them on the backsplash, but they have this underhang under the cabinet above the counter, and you can put like plug mold up there, would meet this requirement as long as it's not higher than what? 20 inches. Then it will count towards receptacles for your 2 foot, 4 foot spacing requirement, okay? All right, other thing, receptacles installed inside of appliance garages are permitted, but they do not count as the required countertop receptacle. That's in 210.52C3. What are we talking about? What's an appliance garage? Well, I don't have a picture for that, but on your counter, if you have this roll top, like a little cubby that you put your toaster in and things like that, and it's actually fixed in place, say in a corner, then that breaks the wall line. You can have receptacles in there, but they don't meet the spacing requirement. So you'd have to start your measurement at the edge of that appliance garage, and then you'd have to have one within 2 feet, right? Because you could put receptacles in there, but again, they're inside of a cabinet, like a cupboard, and they don't meet the spacing requirement. You can have extra ones in there if you want. That's fine, but they won't meet the spacing rules. All right, so let's look at this illustration here. We've got some A, B, and C. We got some good call-outs here. So typical kitchen, right? Here's your wall going around your kitchen. You come into your kitchen, and you've got your counter. Your sink is in the counter, and over here you've got, this is a refrigerator, all right? And you got a little counter here at the end of the refrigerator. All right, all these things that we talked about earlier are now going to start making sense to you. A, the maximum distance to any receptacle along the wall line of the counter measured horizontally is 24 inches. So here's the break in the counter for the sink. I have to have one. I can't go more than 24 inches and have a receptacle. Then I can go up to 4 feet, because if I go right here in the middle, I'm within 2 feet of this receptacle, and I'm also within 2 feet of this receptacle. So that's the 2 foot, 4 foot rule. Now here's the edge. Down here at the bottom, here's the edge of the counter. I have to have one within 2 feet of the edge. Kind of like a break in the wall line when we did the 6 foot, 12 foot. Same here. This is the edge of the counter. I have to have one within 2 feet. So I come in 2 feet, put one, then I can go 4 feet, put one. And if that one's also within 2 feet of the actual sink, then I'm okay. Can it be within 1 foot of the sink? Yep. Can it be 18 inches from the sink? Yep, that's fine. It just can't be more than 2 feet. And the same thing over here, have one within 2 feet of the edge. Think of this sink as actually breaking the wall line. It makes it easier for you to understand. So I'm going to have one within 2 feet, and then I can go up to 4 feet, and then I can go up to another 4 feet. And this is the break in the cabinet right here where the refrigerator is. I got to have it, make sure that it's within 2 feet of the end of this counter. Okay, this one is. And this is the break right here. And then this piece of counter right here is at least 12 inches. Now, if this had been less than 12 inches, then I wouldn't need anything there. But this is 12 inches as it shows here on the diagram, so I have to have a receptacle here. All of these receptacles serving the countertop have to be GFCI protected. Now, notice this receptacle here that's serving the refrigerator. Now, typically, that is also required to be on the small appliance branch circuit. But as you saw earlier, there is an exception that says that this receptacle could be 15 amps or greater, and it could be an individual branch circuit. It doesn't have to be on the small appliance, but the rules in the code act like it's supposed to be on the small appliance, but then it gives you the exception to bring an individual branch circuit to it if you want to, and that's fine. Also, since it does not serve a countertop, it would not be required to be GFCI protected. Unless, of course, if you're familiar with 210.8, if this receptacle happened to be within 6 feet of a sink, then it would be required to be what? GFCI protected. In this case, it's a long way from the sink, so it would not be GFCI protected. Okay? Now, can it be on GFCI? Absolutely. Everybody talks about refrigerators tripping GFCIs. You know what? I've been doing this for many years. That doesn't just happen unless there's something wrong with the compressor of the refrigerator or something. Our refrigerator in my house is on GFCI, and it's run perfectly fine, and it's never tripped it. And I have one of those big Samsung refrigerators. Never had a problem, okay? So even though it's not required to be on GFCI, It could be. Just remember, you can't put a GFCI receptacle back here. Why? Because in 210.8, they're required to be readily accessible. And it would not be readily accessible for testing if it was behind a big refrigerator. Okay, makes sense? So again, most of this, all these out here, you could put a GFCI in the very first one, and then everything downstream would be protected, or you could put GFCI in the panel, and it protects all the receptacles here. Okay? All right, so this is where we're at. And so D right here, that's not required. It's not the countertop. So again, that doesn't have to be GFCI. Now, again, and this one right here, again, is reminding you that E says that any countertop or workspace that is 12 inches or wider is going to have a receptacle. So all of these chevrons. So let me tell you something real quick for you students that are studying for the code to take your exam, whether you're in our program or not. If you're watching this video, don't be in a hurry. If you think this video is long-winded, I'm sorry. That's just how I teach. So look, make sure you pause the video, every one of these, go to these code references, read it, try to absorb it, and then come back and again read the summary here, or kind of sometimes this is just basically giving you for some reason I'm lacking the word, a synopsis of what it says, or sometimes it's word for word. But when you do that, then you're going to get better at understanding the code, and you jump back and forth, and then you get to look at an illustration and go, okay, this all makes sense now. All right? That's ballistic training. It helps you understand everything. Fast track students are used to this, but you need to get used to that in your training. That's why if you're buying just exam questions, that is not the way to learn the NEC. It's not. You might get lucky, but again, it's not the preferred way to learn the NEC, okay? All right, remember, here is C, and again, it's why it's pointing to this. It's just to remind you, the receptacles that are not serving the countertop are not required to be GFCI protected unless, of course, they're within 6 feet of a sink. Then the top inside edge of the sink or bowl, then it would be required to be GFCI protected. Important to remember that. All right, caution. A receptacle installed behind a refrigerator does not require GFCI protection. We covered that. Unless it is installed within 6 feet of the top inside edge of the bowl or the sink, okay, then it would be required to be GFCI protected. And for heaven's sakes, don't put the device behind the refrigerator. That's a little common sense, probably, approach to that. All right. All right, we're continuing on with the kitchen countertop receptacles. It says, and again, you see some good illustrations here. It says required receptacle outlets used to serve the kitchen countertop must be located 1 on or above the countertop surface, but not more than 20 inches. So it can be on or above it, not more than 20 inches, okay, the work surface. Number 2, in the countertop if listed for the purpose. So it could be actually built into the countertop, not face up, but maybe a tombstone or one of those ones that pop up out of the countertop. That is perfectly fine. So that's what it means, that it can be in the countertop if it's listed for that. And number 3, not more than 12 inches below the work surface. Okay. Now this is still allowed in the 2020 edition of the National Electrical Code. All of this changes for the 2023, by the way, and we're going to cover that in 2023 episodes, but we're in the 2020, so that is perfectly acceptable. All right, now it says, receptacles installed below a countertop or work surface shall not be located where the countertop or work surface extends more than 6 inches beyond its support base. All right, so let's see here. Let's look at this illustration here. So here, this receptacle right here, this is C. Obviously, it's GFCI protected. It's in the kitchen. And it can't be more than 20 inches above the countertop. Okay, that's fine. It also could be right here on the side, as long as it's not, any part of this receptacle is not more than 12 inches below the top of the countertop. And also, if there's an overhang right here, this overhang, and here's the support base right here. This is the part you measure, not this part that might protrude out, but this part. This is the base support. This overhang cannot be more than 6 inches beyond this support base. If it is over 6 inches, then you can't put the receptacle there because the cord would extend over and around underneath the actual countertop. So that wouldn't work, okay? Also, I'll remind you something. This receptacle down here, this is the wall space receptacle. It cannot serve the countertop spacing, right? It is to serve the wall space requirement. So this measurement starts right here, and you have to have a receptacle within 6 feet. So that's what that's serving, okay? So now we'll look at the call-outs to kind of tie all these things together. So here's A. Again, A was talking about the 12 inches below, so this can't be more than 12 inches below the surface, and that's important because that also applies to islands and things like that. Next, B says GFCI protection is not needed for receptacles installed along the wall to meet 210.52a, and that's what this one is for, right there, okay? Requirements, unless the receptacle is installed within 6 feet of the top inside edge of the bowl of the sink. So this one right here, if it's within 6 feet of the top inside edge of this bowl, and again, you measure it as the crow flies, folks. So it's not like you go down, here, down, and then over. It would be a measurement like pulling a string from here to the edge and then at an angle down to here. If this was within 6 feet, then it has to be GFCI protection. Even if it's for the wall spacing, it's still within 6 feet of the sink, so it has to be GFCI protection. Same for this one. Obviously, if this is to serve the countertop, then it would be GFCI protected. But if it, say it wasn't to serve the countertop, if it still was within 6 feet of the top inside edge of the sink or bowl, it still would require GFCI protection, right? Now, what about these that are inside the cabinet, maybe for the garbage disposer, or maybe a dishwasher, maybe you using a plug and cord application for that? Well, let's look at these receptacles inside of the cabinet. So D and E. D says receptacles located inside a cabinet or cupboard which do not serve kitchen countertop surfaces, right? Because it's in a cabinet or cupboard, it's not on the counter, do not require GFCI protection unless the receptacle is supplying power to a dishwasher, okay? That type of thing. Now, I'll also tell you this. If that receptacle, check this out, if that receptacle is within 6 feet of the top inside edge of that basin, then it would require GFCI protection. Right? Where does it say that? All right, let's go look because I want to make sure we're all clear on that. All right, so let's go to 210.8 real quick. First time we've kind of dabbled in 210.8, by the way. All right, so see this right here, the ground fault circuit interrupter protection 210.8, and we're talking about, for the purpose of this section, when determining the distance from receptacles, the distance shall be measured the shortest path. I mean, that means straight line, folks, not measuring the contours. The shortest path the supply cord of an appliance connected to the receptacle would follow without piercing a floor, wall, ceiling, or fixed barrier, or the shortest path without passing through a window. Now, in the 2017 code, there was also door and doorway was in here. It's not in here anymore. So what does that mean? If the receptacle is underneath the cabinet, whether there's a door here or not, if it's within 6 feet of the top inside edge of that sink, guess what? The receptacle's in there, irrelevant to the fact that it would be supplying something like a dishwasher, which incidentally does require GFCI protection. It would require GFCI protection anyway because it's within 6 feet of the sink. And they removed door or doorway from this measurement back in the 2020. Back in the 2017, there used to be a door provision there. So you didn't have to measure it because there was a door. That's been removed. So again, at that point, it's going to qualify, all right? And you're going to have what? And you notice here this grayed out language? All of that has changes to it. And so it's going to have GFCI protection anyway. So keep that in mind. Now, as far as the dishwasher is concerned, that one, so 210.8 A6, just so you can see that right here. Here's A6, and this is what it's talking about. where receptacles are installed to serve the countertop. Okay, that's true. And then 422.5A7, that has to do with the dishwasher specifically because it's 422, so it's under appliances, right? But I want to draw your attention, again, to the sink. Where receptacles are installed within 6 feet of the top inside edge of the bowl or sink is going to require GFCI protection. And when it comes to this measurement, no longer does a door break that measurement, whether it's a cabinet door or whatever, that's gone now. So this would require GFCI protection regardless, because I guarantee you, if you look under the sink and you measure from the edge of the sink, top inside edge, those receptacles are going to be within 6 feet, okay? And of course, E says receptacles located inside the cabinet cupboard do not count as the required kitchen countertop receptacle. Well, obviously not, okay? Because they're more than 12 inches below. They're in the cabinet, by the way, and they're not in the countertop, and they're not within 20 inches of the top of the countertop. So obviously, they would not serve the spacing requirement, okay? That just goes without saying. There is a note. Note says, receptacle outlets are permitted to be installed in countertops or work surfaces, but only if the outlet assemblies are listed for installation in countertops or work surfaces. That's what it says in 210.52C32. Now, they make these devices that you actually cut the hole, and these receptacles go down in it. Now, there's two different types they make. Some are hardwired, and those are the ones that are listed that we're talking about. The other ones are cord and plug connected. So you couldn't put the receptacle underneath it, put these in, and then plug them in, and that meet the requirement. That's not going to work. That receptacle is, in theory, under the cabinet and not meeting the rules that we just read. But you can buy those that actually hardwire, and then they pop up above the countertop, or they flip up in the countertop, then those would be okay. That would meet this rule, and they're listed for that. Okay? Just don't go buy the ones that have a cord on them with the attachment plug. Those are basically relocatable power taps, but they're designed in a way that they pop up and look all fancy. That's not the same. And you're going to know the difference by the price. The ones that you buy that are listed, that you hardwire, that are going to meet this rule, those are expensive, $300 and $400 and $500 a piece. Okay? So significantly more expensive. But they are listed for this application. Warning. Okay. Oh, I didn't. I'm showing you the code, but I was reading this. So here's the note I was talking about right here. So if you've got the ones that are going to be installed in the countertop, have to be listed for that, not the cord and plug kind. They have to be the hardwired kind. Okay. And that is in 210.52C32. Another warning. Receptacles installed for countertops and work surfaces as specified in 210.52C shall not be considered as the receptacles required by 210.52A. Okay, so they do not meet the spacing requirement. And I'm going to have to show you, I'm not sure, let's see if I got an example of that. Let's see. I don't know if I have an example of that, so I'll try to illustrate it. So let's see this right here. Let's look at this picture right here. So what if this receptacle wasn't here? Let's just say this wasn't here. And I had a door right here. Okay, just picture a door right here. And this receptacle right here is not here. Please, you with me? All right, so that door has a break in the wall space. So I have to have a receptacle within 6 feet. Well, this wall space over here, let's say I'm counting this right here, and I could not use this receptacle serving the counter to also serve this wall space. This is only for the counter. It's not for the wall space. So all this is saying is the ones for the countertop serve the countertop. The ones for the wall spacing serve the wall spacing. The one on the wall can't serve the countertop. The one on the countertop cannot serve the wall. Now, they are probably going to be on the same small appliance branch circuit, but this is a receptacles placement rule, okay? So it's just something to keep in mind. Just because the receptacle on the countertop, so for example, maybe this receptacle is serving the countertop, right? And this overhang is not more than 6 inches, okay? Well, if I have a doorway right here, and this is wall space, and this receptacle is, say, within 6 feet of this doorway, it could not meet this wall space requirement. because it's here to serve the countertop requirement. You can't do double duty, and that's what it's trying to say. So it means you're going to have to install a receptacle down here, as long as this wall space is at least what? 2 feet. We covered that in another episode. Make sense? All right. All right, folks, that's pretty much the placement. We're going to do a separate video when I talk about islands and peninsulas. Okay, and so look for that video. That's a totally separate one. I really want to just cover the general receptacle spacing requirements in a kitchen. But again, another video, we're going to get into the peninsula and the actual island receptacle requirements for the 2020 edition of the NEC. Now, for the 2023, that just goes all out the door. But if you're in the 2020, then we need to explain it, and we're going to do that in another video. Hey, I appreciate you taking the time with me today. We've been almost an hour in this one. If you really want to learn the National Electrical Code, go right here, fasttracksystem.com. We also have a bunch of free blogs on our website. Go read those. There's a lot of calculation blogs there. They're free. I have some free courses on there. But if you really want to learn the NEC, get into our Fast Tracks program. You'll be amazed what you'll learn. All right? And you can join us on Wednesday nights and bring your questions. We'd love to have you. All right, folks. Till next time, stay safe, God bless, and be safe out there. Take care.
Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee, vanilla latte served to go. I drink it slow. Morning coffee.
Hey everybody, welcome back to Electrical Code Academy. My name is Paul Abernathy. I'm the instructor for today. And we're going to be talking about general receptacle placements in this episode. For somebody that's been in the field for many years, it becomes old hat. Where do you put receptacles? How do you space them? All the things you have to think about. It becomes old hat for you. But if you're really wanting to know where things are supposed to be and not just assume where they're supposed to be, then that's when you get into a good course like ours. And so with that, I want to talk to those out there who need to learn the National Electrical Code. Maybe you're an apprentice, maybe you're a journeyman and you're struggling with the NEC. There is no better way to learn the National Electrical Code than in our programs. So do me a favor. If you just go to this website right here, fasttracksystem.com, go to any of our courses and watch our videos, watch our demos. But if you're trying to really learn the National Electrical Code for an exam, then you want to look at our Fast Tracks Black program. It's based on the National Electrical Code. It's acceptable in every state. We teach the NEC only, okay, for electrical exams, okay? We don't get into OSHA, we don't get into safety, we don't get into local rules. We purely teach the National Electrical Code, but we teach it at a very high level. And our course is very extensive, 19 units, well over 1,200 exam-style questions, competency reviews. You can join me on Wednesday nights, or you can even get the Fast Tracks Plus, which also gives you 12-month access to our exclusive video platform. This is something new. That is called FastTracksTube.com or Fast Tracks TV if you like. You can use that as well. And it has videos that teach the National Electrical Code, but it's not just videos from me. I am bringing in all kinds of instructors into this platform. Okay? Some very well-known instructors will also be featured on this platform because we want you to learn the NEC. It's not about just my content there. We want to help you learn the NEC, but we want to get rid of all the flutter from everywhere else and purely focus on the electrical industry. Basically a YouTube for electricians only, and that's what it is, fasttrackstube.com. So check that out. It's an annual subscription. But if you sign up now, you can get $25 off that annual subscription by just simply using the coupon code 25OFF, all caps, 25OFF at checkout. You'll get $25 off your annual subscription. And you're going to get access to some amazing videos. You're going to get our grounding and bonding series that's in there. It's about 12 hours, I believe. We have a real extensive program on swimming pools, spas, and hot tubs. That is worth it alone. If you were to have bought that or attended that series, you would have paid way more than that. So you're getting access to all of that, plus so much more. And we're adding new videos every week. So it's really going to be an amazing platform. But if you're studying for the NEC, go to this website right here and look at our Fast Tracks Black. Now, if you're already licensed and you're already an electrician, journeyman, or even a master, maybe you want to deep dive. Well, we've got courses for you, and we're talking extensive. We have a Fast Tracks Red program for residential. We have a green program for commercial. We have a blue program for industrial. We even have something called Magenta, which is industrial electricity, and that is a very high level. Okay, that's almost like engineering level. You'll learn so much stuff in that. We also have a purple course, which is grounding and bonding. Some of the best grounding and bonding images and graphics and illustrations that you're going to see anywhere to hammer these things home. We've got electrical theory courses. So it's not just for exam prep, folks. We help electricians who are good become great electricians in our courses with amazing illustrations. And you always get access to what? Our Wednesday night sessions if you want to ask questions. I'm here to help you. Okay, and I'm very hands-on on everything. Anybody that's ever reached out to me know that I answer phones. I do review of the code questions. I do all competency reviews. I'm there to host Wednesday nights. I am very active with my students, and I have been doing that for over 32 years. If you want to know who I am and you want to trust a resource and you're saying, well, anybody can just go on YouTube or Facebook, grab your code book, go to the front of your code book, and look at code panel 5 in code panel 7. You're going to see my name there. And I'm not saying that to brag. What I'm saying is that you can trust the resource. There's a lot of educators out there, but how many of them work that closely with the NEC? I've been serving on code panels for years, and I tell you what, I literally have a passion for teaching people the National Electrical Code. So I encourage you to go verify me. Okay, Google me if you want. I'm here to help you learn, and that's what our program is all about. So give it a shot. All right, so now today we're going to talk about general receptacle placements, and this might be multiple video series on this one, but this most certainly will be part 1, and we'll see how much we can cover in this episode. So let's kind of go look at it. So here's what we got, folks. We're going to be talking receptacles today. We're going to be spending most of our time in Article 210, and we're going to be in Section 52. And that's generally talks about most of our placement type of requirements. So if you've got your code book, and I've obviously got link all geared up so we can go look at the code where we need to. We're going to follow the same principles that we always do. Anytime you see some chevrons, pause this video, go read the code section that it references, and then come back and hit play and keep on getting it. That way you can get the most out of these educational series. Right? So let's talk general receptacle placement. So we're talking about bedrooms, living rooms, where we put these receptacles. So wall space determines the minimum number of receptacles in a given dwelling. Okay, how much wall space you have, measuring it out, it's going to help define how many receptacles you actually have. Receptacle outlets shall be installed in kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, sunrooms, bedrooms, recreation rooms, or similar rooms or areas in accordance with the provisions specified in 210.52a. Okay, so when I talk to people about receptacles, I always tell them the holy grail of receptacle placement is obviously in 210.52. Okay, that's where you're going to go anytime you have an exam question. It talks about how many feet from a doorway do I have to put a receptacle. And all of those type of things are going to reside in Section 52 of Article 210. So it's kind of one of your go-tos that you'll start to remember. You're giving me a question about receptacle placement. I'm going to go to 210.52, and then I'm going to bold scan through, and I'm going to find the answer. Okay. All right, so let's start looking at it. So here we've got a nice illustration of a room, and we're going to show how we would lay this room out. Now, this is laying it out to the maximum. Okay, obviously you could put more receptacles than you want, but we're putting in the specific number that would make us compliant to the NEC. You can always have more. Okay, you can always go above the NEC, but for exams, typically they want you to follow what the NEC says. In the real world, you're going to work with your customer and you're going to put additional receptacles where necessary, but you at least have to meet the minimums. All right, so let's talk about it right here. All right, A is pointing right here. A is pointing right here. A is pointing right here. Now, what is the commonality between all of these that it's calling out? They're all within 6 feet of a break in the wall line. Okay, so this receptacle is within 6 feet of this break in the doorway. This receptacle is within 6 feet of this break. It's within 6 feet of this break. And this one right here is within 6 feet of this break in the door. Okay, right here, break in the wall. So what does it say? It says receptacles shall be installed so that no point measured horizontally along the floor line of any wall space is more than 6 feet from a receptacle outlet. Okay, so that's what it says in 210.52A1. It's a great time to pause and read what that says in the code. And by the way, in our Fast Trax program, we use these chevrons specifically for that. Anytime you see a chevron, we expect the student to stop. Obviously, read what's there, stop, and then go to the code and read what the code says. Why do we do that? Because that moves a student in and out of the reading material into the code book, and then they come back to the material. It makes them a little more comfortable with the material, but it also helps them learn where things are in the NEC, so that when they're in a stressful situation in an exam, they're getting familiar with going into that code book and finding these things out, and it just kind of helps raise that comfort level. Now, if you're in the field, you most certainly need to learn how to navigate the NEC. So anytime you see a code reference, getting into the NEC is going to be so beneficial for you. It's just going to make you better. Trust me, it's one of those things that after time, it just becomes habit forming, and you're going to just be able to whip in and out of that NEC. You're going to be able to look at a question, dissect the key root of that question, and boom, you're off to town. Why? Repetition. Doing things over and over again. There's a method to the madness, so you have to trust me on this, okay? All right, so here you see this receptacle obviously is within 6 feet, so if I were to put a lamp right here, I have to be within 6 feet of a receptacle, so it would be. Now, B, the maximum distance between receptacles is 12 feet. Now, you're probably saying, okay, what do you mean? I thought it says at any point in a wall line, you can't be more than 6 feet from a receptacle outlet. Now, I'll remind you that a receptacle outlet is the actual box in the wall. Okay, a receptacle is a device that goes in that receptacle outlet box. Okay, subtle, but it can be important as you move through the code, understanding that devices are the receptacle, devices are switches, outlets is the location where we're taking the power from the system. Okay, so I'm putting a device in that outlet box. I'm putting a switch in that switch box. Okay, it's a outlet box. Okay, just things to think about as you're starting to your journey and really lock all these things in. It may be old hat for you, but it certainly is worth reiterating again. Now, why 12 feet between this one and this one? Because if I were to go right here in the middle of these two, it's 6 feet and then 6 feet, I'm at right in the middle. I am within 6 feet of this receptacle on the left, and I am within 6 feet of this receptacle on the right. So this point of the wall, I am always within 6 feet of a receptacle. So if I go a maximum 12 feet apart, anywhere in this wall line, if I go right here, I am within 6 feet of a receptacle. I wouldn't be within 6 feet of this one, but I am within 6 feet of this one. So I am compliant. So that's where you hear us talk about this old saying, 6 foot, 12 foot rule. That's what it means. 6 feet from a break in the floor line, and then the distance between receptacles could go up to 12 feet so that no point along the wall line am I more than 6 feet from a receptacle. Okay. Now, you notice here is another break in the wall line. Then this receptacle is 12 feet from this one, but it has to be within 6 feet from this one. Now, in the real world, that may not do. Maybe this one is 12 feet from this one, but now maybe it's 8 feet from the break in the door. What does that mean? Then you're going to have to put another receptacle in here. So that usually means that instead of using this 12 feet, I'm probably going to move this receptacle a little bit to the left. Maybe it's only 8 feet from the other receptacle in order to be able to get another one in here and make it look nice on the wall. Okay, that's an aesthetic thing. And so you might have to add more receptacles to be compliant. But this drawing just shows you the minimum necessary to meet compliance. Okay, so here's the break. You got to have one within 6 feet, and there it is right here. And then you can go up to 12 feet. Don't have to go to 12 feet. You could go to 8 feet. You could go to 9 feet, but you could go all the way up to 12 feet. And then you put a receptacle right here. And then you go another 12 feet, put a receptacle. And as long as that one here is within 6 feet of the end of this opening of this break in the wall, then that's all you would need, and you're done. Okay? So just remember, from an opening, doorway, things like that, and we'll look a little deeper into the code for this, but remember, a break in the floor line, okay, on the wall line, then you have to go 6 feet. So let's say a doorway, right? Then, or a fireplace, or a fixed shelving that's built into the wall, that type of thing. Then that's kind of considered a break in the wall line, okay? Just like if it was an opening, okay? You got to go read the code because it gives you some scenarios, folks, in that. And so in this case, you're measuring from that break, and you have to have a receptacle within 6 feet. So these are pretty evident, right? There's a doorway, doorway, doorway. So that is obviously a break in the wall line. Those make it pretty easy to understand. All right, so we got C here. So let's see. General receptacle placement requirements for a 125 volt, 15 and 20 amp receptacle outlet are in 210.52. So again, I was telling you that earlier, reiterated, that is the holy grail, right? That is the holy grail of receptacle placement requirements in 210.52. Of course, it's also 210.52a, then there's a B, and there's a C. Again, so we're talking for kitchens as well, and all that. So there's a lot there, but that's where you're going to go, right? Now, caution. Says the receptacles required by 210.52a through I shall be in addition to any receptacle that is, number one, part of a luminaire or appliance, number two, controlled by a listed wall-mounted control device in accordance with 210.70a1, exception number one, I'll explain that in a minute, number three, located within cabinets or cupboards, and number four, located more than 5.5 feet above the floor. This is all covered in 210.52, by the way, so I'm going to kind of explain each one of these. So these receptacles are these general purpose receptacles, and these you have to have based on that 6 foot, 12 foot example that we gave you, right? But you could have a luminaire or an appliance with a built-in receptacle. Well, that's okay, but it can't take the place of these general receptacle placement. It's just an extra one. Okay, so you could have it in an appliance in the room, but it can't qualify as the ones that are required by 210.52. Okay, can't meet that. Now, the next one, controlled by a listed wall-mounted control device in accordance with 210.70a1, exception number one. Okay, so what does that mean? Okay, let me give you an example. Your bedroom. Maybe you don't want to have a light in the ceiling. Well, 210.70. Okay, the exception under 210.70a1 says, you know what? I'll let you switch a receptacle in lieu of a lighting outlet. Okay, but you can't switch the whole receptacle. Why? Because it wouldn't meet the 210.52 spacing requirement. It has to be a receptacle that's there, powers on all the time, not where you can switch it off. Now, that doesn't mean that we have to put a switch to meet the permanent requirement that we show in this illustration and add another receptacle and switch it. No, we could simply take a duplex receptacle. Remember, that's two receptacles. Break the tab on the hot side, and the top one be switched, and the bottom one be hot all the time. So the one that's hot all the time meets the requirements of 210.52a, no problem. The one that's switched is being switched in lieu of a lighting outlet in that room, and that is permitted by 210.70A1, exception number 1. Okay, very common in bedrooms, especially when you're doing the efficiency homes where they're trying to keep the costs down and they might not want to put luminaires in the rooms. Well, and they still have to have switched something in the room, right? So it's either a switched luminaire or they can switch a receptacle. You just can't switch the entire receptacle. You could switch half of it and leave the other half hot, and the hot part would meet the spacing requirements, and then the other half meets the switching requirement in lieu of the lighting outlet. Okay, now be careful. There are some places in the code that you can't do that, right? So it's important that you be really aware of that switching, okay? So again, we're going to cover that in other episodes. We're really talking about spacing and placement now. But, I'll just give you a hint. One of the locations where you can't obviously do that is in bathrooms, right? So, but again, we'll get into that in another episode. We're just talking spacing and placement at this time. The next one, it says located in cabinets and cupboards. So, I might have a receptacle that's in a cabinet, but that can't take the place of my general receptacle layout, okay? It's just extra. It can be in there. That's not a problem, right? But I'll give you another example. A receptacle in a kitchen that's serving the countertop, if I have a receptacle up in the cabinet for some reason, all right, that is not going to replace the ones that are still required for your spacing around the kitchen and the spacing on the countertop, which we haven't covered yet, which is called the 2-foot, 4-foot rule. But we haven't really gotten into that spacing yet. But the point is, I might have a receptacle in a cabinet, but that's not going to meet the spacing rules. So they can be there, but they're going to have one that's out on the wall available to meet the spacing rule in 210.52, okay? And then lastly, located more than 5.5 feet above the floor. So let me give you an example here. Say this is my bedroom, and I'm laying out my receptacles, a 6-foot, 12-foot rule, but I want a receptacle up high for a flat screen TV. Now, if that receptacle is, let's say it's this one right here, okay? So let's say it meets the spacing and you put it up 4 feet, that's perfectly fine. Nothing says it has to be 16 inches off the floor, 18 inches off the floor. It could be 2 feet off the floor. Nothing says that it can't be, but the moment that it goes higher than 5.5 feet, then I would have no receptacle in this wall space, and essentially I'd have nothing for this whole span. For 18 feet, I would have nothing as far as the codes determine because I put that receptacle up higher than 5.5 feet. So I would have to add a receptacle down low. That doesn't mean that I can't have a receptacle above 5.5 feet. Sure, I can. But I still have to have a receptacle down below 5.5 feet to meet my placement requirements around the room. Makes sense? So again, you'll see a lot of people that'll have the TVs with the receptacles behind it, and they'll be feeding them from a receptacle that's down low that's meeting the spacing requirement, but they needed to just get power up higher so they can supply that flat screen TV. Perfectly okay to do that, but you got to remember the spacing rules. Okay, so any of these that you see right here, these are can't take the place of the normal receptacle placements that you would have in 210.52A through I. Can't take the place of those. You can have them, but they can't take their place. All right, note, dwelling unit receptacle outlet general provisions specified in 210.52 apply to any part of a basement containing habitable rooms such as dens, recreation rooms, etc. So again, downstairs, if you have dwelling unit receptacles and you have a basement, then guess what? If it's considered a habitable room, and it will be, you have to make sure that you still meet the spacing requirements down there as well. Now, if it's an unfinished basement, no, you don't. Okay, but if it's a finished basement, this 210.52 is going to apply to spacing of the receptacles. You can't have a client just say, oh, I want one here, I want one there, I want one there. No, we have to meet the minimum 6-foot, 12-foot spacing requirements. And of course, you can deviate from that. You don't have to be 6 and 12. You could be 6 and 8, right? As long as you're 6 feet from a door opening, but you could be 4 feet. You could put it at 3 feet from a door opening if you want. Okay, you just can't exceed 6 feet. And from receptacle to receptacle, you can't exceed 12 feet because you can't be more than 6 feet from anywhere on the wall that you touch. You can't be more than 6 feet from a receptacle. So that's our spacing. We call that the 6 foot, 12 foot rule. Okay. All right, let's talk about wall space, right? So when we're thinking of that wall space and we're thinking of the receptacles, sometimes you're going to have smaller wall spaces. Maybe a space between the door that enters into your bedroom and then you have a closet door and you have that wall space between it. Does a receptacle go there or not? Is that wall space, again, we're measuring out for receptacles, and you say, well, I got to have one within 6 feet of the door, but maybe that wall space is only 23 inches between the door to enter the bedroom and the door that enters the closet. Do you have to have a receptacle in that wall space? Well, let's look here. So here's what it says in the code, and you'd be looking at 210.52A21, and it says a receptacle is required for any wall space 2 feet or more in width, and it includes a space measured around corners, unbroken along the floor line by doorways or similar openings, fireplaces, or fixed cabinets, and you heard me talk about that earlier, that do not have countertops or similar work surfaces. Okay, so and we're talking about fixed cabinets that do not have countertops or similar work surfaces. So it's just a cabinet, okay, like a bookshelf cabinet. If it's going from floor to ceiling or whatever and it's permanent, then that is almost like a break in the wall. And you start your measurement from the end of that fixed cabinet, okay? All right, so thinking of it that way. Now, if it's a cabinet that's kind of short and it has a work surface on it or a countertop on it, then that does not break the wall space, and you're going to still have to maintain your spacing in that cabinet. And remember, if you put the receptacle in the cabinet, that's not going to qualify. It would have to be outside of the cabinet, maybe above the cabinet, not more than 5.5 feet to meet that spacing rule, okay? Way important things to really understand. And hopefully you're getting it. If not, what do I always say? You can reach me by going to our website. There it is right there. And you have a contact us feature. You can send us an email. But if you want your question to really be answered quickly and to potentially be on a podcast, make you famous, but not say your name, I'm not going to give the names, but again, we'll talk about your issue, then also you can go to paulabernathy.com. It's a website that I set up under my name in order to be able to ask your questions, and I answer your questions so you get even more resources from our company. We're here to try to help you. All right? We create what I believe the most affordable, full, inclusive program out there, and the support that you get is unmatched by anybody. We're not just selling you a book or a DVD. You can even speak to me, and I will help you understand it the best that I can. And that's, I don't know, put a price on that, okay? Somebody always there to answer those questions for you. That customer support that you really need, okay? All right, so let's kind of look back at here. All right, so let's look at what we've got here. We've got this wall space right here. It measures 23 inches, so no receptacle will be required. And that's what it says here in 210.52A21. It's only for wall spaces that are 2 feet or more. So 23 inches is not 2 feet. No receptacle. So if this was between a closet and the entry into the bedroom, that piece of wall right, no receptacle would be required. You may put one, but it's not required. Now, that same wall space, if it was measured 24 inches or greater, then you're going to have a receptacle in there, okay? So if this one's example is this one's 24 inches exactly between the door opening and the edge of a fireplace or edge of a fixed cabinet, right, with no shelving on it, then guess what? Or the edge of a doorway. If that is 24 inches, then you're going to need a receptacle there, okay? Another myth that people have, and I'm just going to throw it out there, this one shows the ground up. Can you have the ground up or the ground down? The code doesn't care. That's another myth that people seem to perpetuate out there. They say, oh, you got to have the grounds up, grounds down. Well, this is what we do in our city, or this is what we do in our town or our state. Okay, that may be true. Maybe your state amended something or did something weird. But as far as the NEC code is concerned, we don't care if it's up, down, left, or right. Now, using logic, typically, if you're going to do it sideways, then you're going to do it with the neutral side up. Or if you're going to do it with the ground up in commercial applications where they use metal cover plates, they tend to like the ground up. Why? Because if the cover plate comes loose and falls down on the attachment plug is maybe sticking out a little bit, then it's going to fall down and the metal cover plate's going to hit the equipment ground terminal that's from the attachment plug, right? The round one that goes in there. Then it's going to hit that. So a lot of people like to have the ground up if they're using metal cover plates. But there's nothing in the code. Now, that's not to say you have a local ordinance. Okay, so again, that would supersede the code. But when I teach the code, folks, I'm teaching the national electrical code. I cannot teach your local jurisdiction. I can't teach what you might have amendments. It's too many states and too many amendments. I'm trying to teach people all over the country. So I stick to the NEC. Make it simple for us, and it teaches you what you need to know. There's nowhere in the code that says the orientation up or down, left or right of a receptacle. Now, there are code requirements about receptacles being face up on cabinets, for example, or underneath a cupboard. Okay, under a sink in the kitchen, can't be face up. But you also see that it's okay to have receptacles in the floor. And those are face up, but they have special boxes designed for those. Okay, so many rules to learn. And in our Fast Tracks program, you learn all those things. That's why it's so extensive. All right, so let's talk about maximum distance to a receptacle. And again, we kind of looked at it, and I kind of gave you all this already, so this should be just, this will hammer it home. Let's put it that way. This will hammer it home. So let's look at A. So here's your typical layout in your room, okay? This is the end of this, say it's a doorway over here, right? And you got your receptacle, and this one's within 6 feet of the doorway, let's say, right? And then it goes from here, it goes to here, that is 12 feet between these two, okay? If I put a lamp right in the middle, that 6-foot cord would reach this receptacle or it reaches this receptacle. Same as over here. So that's all we're saying. The 6-foot, 12-foot rule means 6 feet from an opening or break in the wall line, and you can go a maximum of 12 feet because if you did so, if you went right in the middle and touched the wall, you'd be within 6 feet of that receptacle, 6 feet of that receptacle. You move 1 foot to the left or 1 foot to the right, you're still within 6 feet of that receptacle, or if you move this way, you're within 6 feet of that receptacle. That's what you're trying to do. The standard cord is 6 foot in length, so we have to make sure that we're discouraging the use of extension cords. So thus we call this 6 foot, 12-foot rule to make it simple to remember, right? So here you go. It says, an easy way to understand the placement of dwelling receptacle is to imagine having a floor lamp with a 6-foot cord. Anywhere this lamp is placed around the wall, there should be a receptacle within reach without using an extension cord. That's what we're trying to achieve, right? Now, even when placed beside a door opening, the outlet should be within reach, right? Because it's supposed to be one within 6 feet of a break in the wall line, right? It says, if the lamp is placed next to a wall with at least 24 inches wide, right? So maybe that's that space between the entry into the bedroom and a closet, right? An outlet should be available within that wall space because, again, 2 feet or more requires an outlet. So maybe that is the perfect place to put a lamp. And that's why the code requires one to be there if it's 2 feet or more in wall space. Kind of see how all that works? It's all done for a reason, folks. It's not to overcome. Now, can I have more in here than this? Could I have one at 6 feet, then have one right here at 6 feet, then I have another one right here at 6 feet, and then have another one say, sure, you could if you wanted to. But that's not what you're going to be tested on an exam. We're going to want to know what the rules are, and it's assumed that you're going to be as efficient as possible. So the 6 foot, 12-foot rule will be the most efficient way to do the installation. But in the real world, you can put as many as you want. Okay, that's not a problem. There's nothing in the code that says the receptacle, other than to meet the spacing. You could add a bunch of extra ones if you want to. It's totally up to you, okay? Now, B, right here, is the maximum distance to any receptacle along the floor line of any wall space measured horizontally, and it shall be 6 feet, okay? So, again, oops, let me shut this right here. So, again, wherever I put this lamp with this 6-foot cord, I'm going to be within reach of a receptacle. Now, when you're measuring the wall line, again, this is where people sometimes will think, well, when I'm measuring it, what about the room is not perfectly square? What if it hasn't? Then you're going to follow the contours of the actual room. Okay, so here you see right here, here's a receptacle, and then the maximum distance is 12. So 5 plus 4, 9, plus 3 is 12. But here you measure to the corner, then measure this wall space, and then from this corner you measure this one. So together, this is 12. But you measure what? You measure around the corners. Okay, so an electrician with a tape, typically I would measure from here to here, and then I'd go around and measure here to here, and then I would measure here to here, because that gives me fixed points to try to measure rather than try to drape out this tape, that type of thing. Okay? But you measure around the walls, the contour of the walls. Fixed panels. So in that wall, when you're doing your measurement, some people say, well, Paul, how do I address maybe there's a sliding door? Maybe this is a living room and I'm doing my 6 foot, 12 foot measurements, or kind of, what about a fixed sliding door? Well, you've got two pieces to a sliding door. You got the sliding portion and you got the fixed portion. I'm going to keep it simple for you. The fixed portion of a sliding door is considered wall space. You treat it like it's a wall. It might be glass, but for all intents and purposes, imaginary that it is just that gypsum board extends all the way out to the edge of the fixed portion, right? So in this case right here, if we're measuring, and you know the rule is we have to have a receptacle within 6 feet of the opening, well, you measure from the edge of the portion that doesn't slide, and you measure 6 feet, and there's that receptacle right there. Could it be at 5 feet? Yes. Could it be at 4 feet? Yes. But can't be more than 6 feet away. But this fixed portion counts as wall space. Okay. Now the sliding portion makes sense. Slides open. That's a break in the floor line along the wall space. So your measurement starts here at the edge, and then it has to be within 6 feet from this side. This is your break in the wall, and this is your break in the floor line right here. And you measure 6 feet. And then from this one here, I could go what? I could go up to 12 feet. Okay. But that's how you treat the break in the floor line on a wall when we're talking about a sliding glass door. Okay. Now, where do you get all this? Again, what do I say to do in the program? Here are these chevrons. Go and read it, because that's what's going to give you basically the information that we tell you here. But if you're in the program and you spent good money for the program, or you're watching this video, you want to get the best out of it. Pause the video. Look at that code reference. And go to your code book. Read it. Nothing should take the place of really reading the code. And even if we paraphrase it here, the concept is for you to read it, and it helps you comprehend it. Because you see what we said, then you go and read it, then you come back and you look at the illustration again, and it all starts to make sense. Folks, this isn't done by accident. This is done for a reason. Right? This is what makes our course so much different than everybody else's. I can tell you right now, you go online and you Google exam prep or electrical, and you're going to see books after books after books that claim to teach you to prepare for an electrical exam. The problem with those is that it usually is heavily just questions and answers. That's not going to build on your knowledge base. You need something that gives you the code, works you into the code book. It's worth your investment. And being an electrician is a career. This is your living. This is your job. This is why we teach it this way. I want you to be able to retain this stuff. That's why it's so important to me personally. Okay. So anyway, now let's look at C. It says the maximum distance to any receptacle along the floor line measured horizontally shall be 6 feet. Okay, that's in 210.52A1. And so as you see right here, 6 feet from the break in the wall line, right there, that floor line at the wall, 6 feet. Right here, other side of the break, okay, in that floor line, right here, measured 6 feet, receptacle. Now, could it be at 5, 4, 3, 2? Absolutely. But the maximum is 6 feet, okay? All right, let's talk a little bit about fixed room dividers, because that's going to come up as you start going through 210.52. And you're like, well, first of all, what's a fixed room divider? It could be a railing. It could be a cabinet. or something that actually divides a room. It might be a freestanding bar countertop. Maybe in your kitchen, you actually have an island that's actually a counter that's separating the living room from the kitchen. Maybe that is the room divider. Okay, every layout's different. But electricians have to take all these things in consideration, and an inspector has to work with you because they also have to look at these things and take it all into consideration. But we're going to give you one when it comes to rail. We're going to make it very simple. All right, so let's look at this right here. So here's a room, and it's kind of weird. I don't know why this would be here. Only time I typically see something like this is maybe there's some steps right here going down to a landing in a split level, and this is kind of overlooking that stairs that go down. That's where it was in my house years ago when I was back in Virginia. So at any rate, here's your railing. Okay. Now let's see what it says here. It says the space afforded by a fixed room divider, such as railings or freestanding bar type counters. Now, when it says such as, it does not mean just these two examples. So again, it could be some other divider that divides rooms or spaces. And it may not be railings. Okay, it may be a freestanding bar type counter. Okay, it might be a freestanding like a half wall bookshelf. Okay, those are fixed room dividers and things like that. Now, if it's a wall with gypsum board on it, then it's just a wall like a normal wall. Even if it's a knee-high wall, it's still a wall. Okay, so you would have your receptacle requirements, and those would be like we discussed before. All right, so again, this is not an all-inclusive list when you see such as railings or freestanding bar-type counters, so you got to use some common sense. But in this case, we're going to say this right here is a railing. Here it is right here. Now, the receptacle outlet in or on the floor are permitted. Receptacles located more than 18 inches from the wall or room divider may not be counted as the required receptacle. Okay, so let's point. Now that is in 210.52A3, so let's talk about that for a second. Floor receptacles. Can I have floor receptacles instead of the receptacles that are actually in the wall? Absolutely. As long as they're located within 18 inches of the wall. If they're any further than that, like maybe you put it out in the middle of the floor for a lamp, maybe that's your floor design, and it's out in the middle where you'd have a coffee table and a recliner, and it is out in the middle, then that's an extra one. That is certainly not meeting the wall requirements. That's just an extra one. You can have extra ones all over the place, right? But in this case, if you look at here, here's the end of that wall, or in this case, bar. But if this was a half knee wall with gypsum on it, just like these walls over here, then it would still be a wall, and so it would still apply. Here from the edge, you come in and it can't be more than 6 feet, right there. Now, we're obviously not going to put it up in this railing, so that's why this one's on the floor. But if this was gypsum board and this was a half wall, a knee wall, or whatever it was, then you would expect it to be mounted in the wall. But could it be in the floor? Absolutely, as long as it's not more than 18 inches. Now, the cost factor to do this is probably, in this case, it's the only thing you could do because it's rails. But the only other time that I've ever seen us use floor receptacles like this is where I've done a dwelling before where it had one wall of the house was nothing but glass. And people argued and people said, well, I can't put it in. Obviously, you can't put it in the glass, but you still have to have the receptacles. It's still considered wall space, right? It's fixed like that fixed sliding door. It's still wall space. So you'd have to put them in the floor. Now, in this case, the customers were going crazy because it was a concrete floor, and I still needed those receptacles. And so they had to put receptacles that were in the floor, and they were special boxes, special floor type boxes, because they were in the concrete and they were expensive, but they had to have them because I had to have those receptacles. And that receptacle had to be within what? 18 inches of the wall in order to qualify to meet the wall space requirement. Okay? So it is okay to put them in the floor. Just you gotta install them within 18 inches of the wall to qualify. Note, not all types of receptacle boxes are suitable for floor installations. That is so true, folks. A lot of people are just sticking nail-ups down there and other things like that. Again, not all of them are suitable for it. Okay, so make sure you do pick one that's suitable. There's different types of boxes may be required for different types of floor construction. That is wood or concrete. In our case, it had special boxes that were designed to go in the concrete. Receptacle floor boxes must be listed specifically for the type of floor in which they are to be installed. Where does it say that? Again, code references, folks. 314.27b. Take the time. This is important. Pause. Go look that up in the code. All right. I'm not going to do that for you this time because I want you to do it. Pause this video, go read it, and then come on back and you'll see why this all makes sense. All right, let's talk about miscellaneous receptacles. So we already learned about the spacing. We've learned about how we do that. We haven't covered kitchens yet. That may or may not be in this episode, spacing. But again, if it's not, it's going to be in the next episode we do. So look for it. But this spacing is, we'll just call this miscellaneous receptacle spacing in addition to those that are required by 210.52. So here you go. And we saw them earlier. We touched on them a little bit, but here we're going to get a little more detail. Remember, luminaires or appliances with the built-in receptacles, they're permitted, okay? But these receptacles do not count for the spacing requirement. But you can have them if you want them, right? You might, have you ever seen in a hotel where they have the luminaire and it has a built-in receptacle? That's fine. Obviously, that doesn't have anything to do with the spacing requirements. It's an additional, for your convenience, another receptacle, but it's certainly not going to meet the spacing requirement. Now, let's look at A. All right, so where's this one at? All right, locate this one's at 6 feet right now. For some reason, they put this one up high. Maybe this is for a flat screen TV. Okay. Although receptacles located more than 5.5 feet above the floor are permitted, and you could do that. I mean, you could put that receptacle above your cabinet, let's say in the kitchen, to do like accent lighting. You can put a receptacle up high for something else, whatever you want. It still just can't meet the spacing requirement. It's an additional one. You put whatever you want, but you still got to maintain the spacing stuff, right? All right, so that's what that is. So this is 6.5 feet, so that's not going to qualify. So that's why you have this one down here. Okay. B, this one, notice this one's inside of a cabinet. And so if this was 6 foot, 12 foot spacing, and then it ended up being behind a cabinet, so then the carpenter comes in, or the cabinet folks come in and cut it in back here, and your inspector comes in and fails you. Why? Because these inside of a cabinet or cupboard do not count the same as these ones out here that are for the spacing. Okay? You can have one in there, but it's additional. It's extra. Okay? It doesn't meet the spacing requirement. So that's what we're talking about with B. Although receptacle outlets within a cabinet or cupboards are permitted, they are not to count for the required receptacles in 210.52. They're just there. If you want to have extra ones, that's fine. Now, note, height requirements for wall receptacles are not defined. Okay, so nothing says that they have to be at 10 inches, 4 inches, 2 inches, 1 inch, 14 inches, 16 inches, 18 inches, whatever, 5.5 feet or less than 5.5 feet. Have them where you want, okay? Personally, I always put mine at 16 inches to the top, but there's some people that put them at 18 inches to the top. The code doesn't care. That is going to be fair. Now, where may this make a difference? Well, if you're doing dwelling units, for example, in a multifamily building, then they may have an ADA requirement in your local jurisdiction, might have adopted that says the receptacles and switches and all that kind of stuff have to be at certain heights. Because of an ADA, not because of the NEC, but because of ADA, okay? So that is for the Disability Act and that type of thing. But that is typically something you'll see in a multifamily dwelling, in the individual dwelling units in apartment complexes and things like that. Not so much in a dwelling unit, okay? You wouldn't see those things. All right, what about balcony handrails? Okay, so this is an example just like the one before, so this is a no-brainer. Here is a balcony overlooking, let's say, a living room, and maybe this is a loft area. It says A receptacle floor box must be listed specifically for the type of floor in which it is installed. That is, again, 314.27b. And of course, this is considered wall space. So we're measuring this fixed wall space here. I have to have it. Now, I obviously can't put it in here in the balusters. That'd look kind of stupid. So I'm going to put it in the floor. But it has to be within what? It has to be within 18 inches of this rail. Okay? So a floor receptacle may be required if the balcony handrail is longer than 6 feet and the area is one listed in 210.52a. So it's one of those areas that we were talking about, living room, dining room, things like that, or similar area. In this case, if this is longer than 6 feet, all right, to the end, then obviously I have to have a receptacle within 6 feet of the end of this, this balcony rail, okay? I tell people to think of this as, forget that it's a balcony. Forget that that's a rail. It's a wall. And something could conceivably be put there, whether it's a table with a lamp on it or something. Again, we don't want extension cords. So we want to make sure that we have the receptacles and treat that as wall space. And if you have to put in the floor ones, just make sure you're putting in the right type of floor box. And it'll have an associated cover that is also part of that, listed for a floor box. All right, now, what about if you encounter electric baseboard heat? Now, the National Electrical Code specifically doesn't say that you can't, if you have baseboard heat, electric baseboard heat, it doesn't specifically say that you can't put a receptacle above it. However, the manufacturer's instructions will tell you that you can't put it above it. Okay, so and if it's the manufacturer's instructions, you have to follow that. Okay, heat does rise up, and if you plug something in there, the cords would drape down and potentially catch on fire. So typically, you're going to see this in the manufacturer's instructions. But again, this is a long baseboard, right? Look at this thing. This is 16 feet long. So if I'm measuring around the room, I got to have a receptacle in there. So this might be a problem. So if you see A, it says a baseboard heater more than 12 feet in length does not eliminate the requirement for 210.52A1 receptacle. The receptacle is still required. A receptacle is still required for the wall space containing a baseboard heater. So it might be something you have to put in the floor, or you can get baseboard heaters with sections in there that are designed to put a receptacle in it. And you could have the receptacle built into the baseboard. Now, it's not supplied by the power that's coming to the baseboard heat. You still have to bring your branch circuit that you're using for the receptacles around the room. You'll come into that specific section of that baseboard to power that receptacle. Okay? But again, most of the manufacturers of these baseboard heaters will tell you, do not put a receptacle above my baseboard heater. Okay? So note, listed or labeled equipment must be installed and used per any instructions included in the listing or the labeling. That's a 110.3b. So I could buy one of these baseboards and it has a section again in the middle that may hold a receptacle, and boom, I can meet this rule and not have a problem. Okay. Now here's the informational note, folks. It reminds us, listed baseboard heaters, including instructions, may not permit their installation below a receptacle outlet. Okay, and where does it say that? Where does it remind you of that? So you have to go look at what the manufacturers say. That is an informational note under 210.52, and it's also again reiterated under 424.9 in an informational note to do that. If the manufacturer doesn't say that there's a problem with it, then you could do it. I would just use a little common sense. And since heat rises, I would probably put one out here on the floor within 18 inches of the wall. Or I would get a baseboard that has a receptacle that's integral, a component of that baseboard. And they do make those. Okay, so those are the things that I would do if I ran into that specific situation. Also remember, this typically applies to electric baseboards. You're typically not going to find these instructions for gas type of baseboards. So again, can they be above a gas baseboard heater? Yeah. Code doesn't say anything against it. You still got to look at the manufacturer's instructions, but I can tell you most of the ones that I've seen when it comes to electric baseboards will say not to put a receptacle, put the baseboard below a receptacle. Okay. And they do offer some other options in order to do it. My point here is just because it's inconvenient for you and they put that baseboard in there, you still have to follow the receptacle requirements for spacing. Still have to have it. Can't say, what am I supposed to do, Mr. Inspector? The baseboard's there. I can't put a receptacle above it. I guess I don't need one in that wall. Not the case. Still need to do it. All right, and here you go. Here's a good example of one. So this is, I'm glad this is here. I forgot that it was here, but I'm glad it's here. So receptacles mounted in a baseboard heater. They do make these, okay? So A, it says permanently installed electric baseboard heaters equipped with factory installed outlets or outlets provided as a separate listed assembly. Means you can buy the baseboards and you can buy this piece that these baseboards connect to that holds a receptacle, right? By the manufacturer shall be permitted as the required outlets for the wall space utilized by such permanently installed baseboard. So that's perfectly fine. You're still meeting your spacing requirements, but this typically would come from a manufacturer, and you see right here. But this receptacle is not powered by the circuit for the baseboard. This receptacle, again, shall not be connected to the heater circuit. Okay? It's going to be connected to the regular branch circuit. So typically what happens is you have a cover you pull off or the receptacle mounts in it, and in the back of it has knockouts, and you got to make sure that you route your branch circuits, your non-metallic sheet cable as you're going around the wall, poke it in to this receptacle, and you come back in and go out and continue on to the other receptacles, okay? And you'll make everything up in that specifically designated space. And this would meet the spacing rules. So if I had a receptacle here and I could go up to 12 feet, that might be that one right there. And then from here, I can go another 12 feet and put another one over here if I want. Okay, that would be okay. Again, factory, it's made this way. Or you can buy baseboards that come together and does have an assembly that goes in the middle that gives you that room to have that receptacle that goes there. And that is required to meet that spacing. You can't just say, oh crap, I got a baseboard heater on that whole wall. I don't need no receptacle. Yes, you do. Okay. Yes, you do. All right. Okay. So this gets more into the receptacle boxes. So we're kind of out of placement stuff. So we're going to come back to me, and we haven't talked about kitchens, right? So let's come back to me real quick. So we're going to cover the receptacle boxes and all the nuances about the metal boxes, grounding, bonding, and all that kind of good stuff. We're going to cover all that in other episodes. So hopefully you got something out of the placement. This is your general provisions. We're going to get into the placement for kitchen receptacles and all that type of stuff and spacing in another video. Because again, I want to keep these videos, about an hour or less, and to help you be able to absorb it and watch it in a full sitting. But I want you to make sure you subscribe to our fasttrackstube.com because we're going to have other videos and we will go into these other details. So just hunt for them and you'll be able to find them. So we're going to go into the receptacle requirements for kitchens and things like that in the next episode. So hopefully you got something out of this episode, folks. Till next time, stay safe. God bless. And again, if you want to get a great course on learning the National Electrical Code, just go right here and watch our demo. FastTrackSystem.com, click on the Fast Tracks Black course, watch the demo, and you'd be amazed how this program has flashcards built into it. It makes it so easy to remember things. It has a README feature where it'll read all the information for you, and you just listen, kind of that ballistic approach. You can do bookmarks, you can increase the size, you can print it off, you can do anything you want with it. You own it for a whole year. You can print every page if you want. There's just so much here, and I look forward to seeing you on Wednesday night if you join our program. I appreciate you all, and thank you for making Electrical Code Academy a success. I couldn't do this without you, so I do appreciate every one of you. I will never take you for granted. I appreciate you. Till next time, folks, stay safe. God bless. Hey everybody, my name is Paul Abernathy and welcome back to Electrical Code Academy, where we talk about the National Electrical Code and we try to teach you the important aspects of the NEC that you can really use in a day in and day out basis. Now, let me talk to you about something. If you're trying to learn the National Electrical Code and you find it hard, we make it easy. Our Fast Trax program is the most comprehensive program you're going to get on learning the National Electrical Code, but if you're preparing for an electrical exam, we teach you what you need to know to be successful in an exam. But maybe you need more than that. Maybe you want to deep dive now. Now that you've kind of gotten your license, maybe you've used our program, our Fast Trax Black or our Plus, which is available right there at fasttracksystem.com to get your license, or maybe to learn the NEC at a very high level. But now maybe you want to deep dive. You're a residential guy and you want to create this learning curve reduction. Means you want to learn everything you can learn room by room by room by room. We've got programs for you. We got the Fast Trax Red, which is our residential wiring program. We deep dive into all the residential code when it comes to electrical. We have the Fast Trax Green, which is commercial wiring, all of those things with motors and transformers. We have the industrial course, which is the Fast Trax Blue. If you're into industrial wiring and all that type of stuff. We've got grounding and bonding courses. Everybody needs to take a grounding and bonding course, a good grounding. In fact, your employer should pay for that because the majority of the things that people do wrong are associated with grounding and bonding. Now, who am I to tell you all this? Well, again, my name is Paul Abernathy. I'm the creator of the Fast Trax system. I have been doing this for over 30-some years. If you go to the front of this code book, you'll see my name in Code Panel 5 and Code Panel 17. So I'm not a fly-by-night YouTuber. I've been doing this for many years. And long before people knew what podcasts and video streaming was, I was doing it and I was loading it upline on AOL. You remember AOL? And I would upload it in a repository and I was sharing with people around the country. And then as we grew, we were able to create websites and expand it. So we were probably one of the first ever doing it online. And so I have taught over 50,000 students, both in classroom, online, and again, probably way more than that if you think about all the people that are taking my courses. And I love living vicariously through all of my students. If you want to really start to learn the NEC, whether you're already licensed or you're trying to get your license, go watch some of the demos on our website, fasttracksystem.com. You're going to be amazed. And if you want some of our great videos, go check out fasttrackstube.com or fasttrackstv.com if you want. And there you're going to get a lot of videos, not just by me, but by other educators in the industry that we have ferreted out and made sure that they are very valid and they're educational and they're not just a sales piece. They're really trying to teach you something in the National Electrical Code. Then you might want to subscribe to our Fast Trax Tube. Now, if you want a discount code, I'll give you one. Just go and check out at fasttrackstube.com. That's for our annual membership to our video platform. Use the checkout code 25OFF, and that's OFF, all caps, 25OFF. And you'll get $25 off your annual subscription. That's a way to support us, and that's the way we recommend. And you'll get access to a lot of video series that we have out there, our grounding and bonding series. I also did a secondary conductor and branch circuit conductor webinar. It's available there as well. Plus our swimming pool, spas, and hot tub series is all there as well. So check that out. It's all included in the Fast Trax Tube. Okay, so there's many ways that you can learn from us. Okay, enough of the sales pitch, right? Let's go on and get into it. So this is a continuation video. We're going to be talking now about receptacle placements. We have another video on that, so make sure you check that out for kitchens. But now we're going to be talking about peninsular and island receptacle placement. Now, this is very specific to the 2020 edition of the National Electrical Code because in 2023, this all changes. So again, if you're studying for the 2020, then this is the right place for you to be. So let's go on and get into this. All right, so if you're in our Fast Trax program, you'll recognize this. We're in Unit 7. This is 1E, and it's peninsular and island receptacle placement. Now, in kitchens, pantries, breakfast rooms, dining rooms, and similar areas of dwelling units, receptacle outlets for countertops and work surfaces that are 12 inches wide or 12 inches or wider okay, shall be installed in accordance with 210.52C1 through C3. It means you have to have a receptacle. So if you're in the kitchen or breakfast room or dining room and you have a countertop surface, okay, if it's at least 12 inches or wider, then it has to have a receptacle. Of course, the small appliance branch circuits, minimum of 2, are going to be what supply these receptacles in this kitchen, pantry, breakfast room, dining room, or similar area. Like a similar area would be like a nook inside of a kitchen area. Okay, so that's what you're going to have. So we're going to be talking about the receptacle placement now, and shall not be considered as receptacle outlets required by 210.52A2. What does that mean? That means that these receptacles are to serve the counter. They're not to serve the rest of the wall space that's in those rooms. Okay, like you're in your kitchen, you have normal wall space, and then you have the space that your counter's connected to. Well, that wall space, that also requires receptacles, and you would space those in accordance with the 6-foot, 12-foot rule, and we covered that in another video. So again, go watch that video if you want to know what 210.52A is about when we say 6-foot, 12-foot rule. But remember, receptacles for the countertop are different than the receptacle requirements for the wall around the room. Okay? Now, for islands and peninsular countertops and work surfaces, receptacle outlets shall be installed in accordance with 210.52C2A and C2B. Okay? So those are the ones that you need to key in on right here, right there, when it comes to islands and peninsulas. Now, as I always say, when you see code references, more importantly, when you see the things that are in the chevrons, you want to make sure that you go to your code book and you read it every time. Anytime you see a chevron in our course or in my videos, go ahead and pause the video. Go read it and then come back and things will start to make more sense to you. And that's why we do it. That's why we have the chevrons. All right, so let's go down and look here. At least one receptacle shall be provided. Okay, so we're talking. So this is whether it's an island or a peninsula. Okay, this is what we're talking about. We have to have, what is the rules to determine how many receptacles we need? All right, so let's start looking at the math here. You have to have at least one receptacle shall be installed for the first 9 square feet. The first 9 square feet or fraction thereof. And what's a fraction thereof of 9 square feet? 8 square feet, 7 square feet, 6 square feet, 5 square feet, 4 square feet. All of those are fraction thereofs of the first 9 square feet. Okay, so you have to have at least one. Right? Then it goes on to say, a receptacle outlet shall be provided for every additional 18 square feet or fraction thereof of the countertop or work surface. So that's covered in 210.52C2A. Okay. So again, we're going to look at all that and we'll kind of break it down. I'll show you an illustration and this will start to make sense. Trust me, it will make sense. And we'll do the math. Now, when it comes to a peninsula, so that rule still applies, whether it's an island or a peninsula. But when the peninsula is particularly involved, it says at least one receptacle outlet shall be located within 2 feet of the outside edge of the peninsular countertop or work surface. Additional required receptacles outlets shall be permitted to be located as determined by the installer, designer, or the building owner. That's so important. So the first one, the first 9 square feet, the first one has to be within 2 feet of the outside edge of the peninsula. Now, if it's bigger and it has the next 18 square feet, then you can put that anywhere you want as the installer, the owner, wherever they want. But I have to have at least one within 18 inches, within 2 feet of the outside edge of that peninsula countertop surface. Okay? We're going to see what that is all about. We'll look at an illustration. Okay? So that's the rule. So islands are simple. Peninsula, the only thing that takes that to the next level is the fact that you have to have it within what? Within 2 feet of the outside edge of the peninsula countertop. All right, so let's look at it. Here we go. A A is referring down here, so we'll look at A. So here's our layout. Here's A. And this right here, as you see this sticks out right here, this is your peninsula. Okay? And the easiest way to remember a peninsula is that it is only open on 3 sides. One side is a abutting wall. Okay? Whereas the island is exactly how it sounds. It's island. It sits out in the middle, and none of the walls are in contact. None of the sides of the countertop are in contact with any wall. All right? So let's see here. We're talking about A right here, pointing right here. So here's what it says. It says a peninsular countertop shall be measured from the connected perpendicular wall. Okay, so that's how we want to measure it. So let's see here. So here's the wall, and it's perpendicular, okay, running in opposite direction. It's perpendicular of the peninsula. So this way, the peninsula is running this way. Okay, you see my mouse? It's running this way, but the wall's running this way, perpendicular. So the measurement is from that wall out. That's how you do the measurement, okay? And then, of course, that's the way you measure out, right? And then, of course, you've got the depth of the countertop you have to take into consideration when you're determining what? The square footage. All right, so let's look at this. So that's where the measurement starts. B. And what is B? All right, B is right here, talking about the peninsula. Starting the calculation. Calculate the square footage area of the peninsula countertop. All right, so let's look at it this way. Let's look here. So this measurement here says it's 120 inches. So 120 inches. All right, so 120 inches, all right, is 10 feet. So that's where we got the 10 foot right here. All right, I'm going to blow this up so you can see it. So that's the 10 foot. And the width of it was what? Right here, this measurement, 48 inches. So it comes out 10 feet, and the width of it is 48 inches. So this far, 10 feet, depth 48, okay? So we're going to do the math. It is going to be what? 120 divided by 12 is 10 foot, okay? So 48 inches is 48 divided by 12 is 4 foot. So it's 10 times 4. And that is 40 square feet. So how's that going to work? So if the square footage for this peninsula right here equates to 40 square feet. Remember, first 9 square feet requires 1, and that has to be located where? Within 2 feet of the end, okay, and that's why that's there. And then the other one can be placed anywhere you want, okay? So let's look at this. So 40 square feet is what we calculated. The minimum required receptacles, all right? 1 receptacle is required for the first 9 square feet, so we take the 40, and we take 9 from it, that's going to be the 1, and that leaves me 31. All right, so we got the 1, so now the remainder is 31. And remember, it said every additional 18 square feet and fraction thereof. Okay, so then the 31, you divide it by 18. So in that case, we'll take the 31, and we're going to divide that by 18, and that is 1.72. Well, you can't have a 0.72, so that's going to be 2, all right? So the total number of receptacle, or I shouldn't say receptacles, the total number of outlets, that's important, outlets. Receptacles go in the outlet. The outlet, this is an outlet rule. The total number of outlets that we're required to have is what? Overall, we're going to have 3, all right? Okay. Now, with that scenario right here, the first one is right here. It's within 2 feet. And then the other ones can be wherever you want them to be. Now, incidentally, these receptacles that you see on this wall, they might be here because of the normal wall spacing requirement. Well, they can serve double duty. If they're here and they're in the footprint of this peninsula, okay, then guess what? They can serve also as the other receptacles for this peninsula. And they are serving double duty. They're serving the wall spacing And they're also serving, they're in the footprint of the peninsula, so they're also the other two that are serving the peninsula, and you've got more than enough receptacles for this peninsula. Make sense? So that's how you apply that. So let's keep on getting it here. And so next we'll go and do, let's do the island now. Makes sense? All right, let's do the island. So this island is 48 inches by 30 inches. Okay, so we need to find out what we're dealing in feet. So 48 divided by 12, okay, is 4. And then since this is 30 inches, 38 divided by 12, I should do this so you can see it. 38 divided by 12 is 2.5. Excuse me, 30 divided by 12. So 30 divided by 12 is 2.5 feet, square feet, right? So what do? You take the 4 square feet and you multiply that by 2.5 square feet is what? Let me do it. 4 times 2.5 equals 10. Okay, got your calculator. Work it out. Just because it's on the screen, don't take that for granted. Work it out. So now that we know that it's 10 square feet, we know that the first 9 square feet requires at least 1. And then the next 18 or fraction thereof. Well, if I take the 10 minus the 9, that leaves me with a remainder of 1 square foot. But that is a fraction of the next 18. So that means we need how many receptacle outlets? 2. Okay. So the additional receptacle outlet is required for the remaining 1 square foot. So you need 2 overall. Now, on this island, since it's flat across the entire surface, you are permitted to either put it in the island. You can pop it up. Again, you remember, it could pop up above it, okay? But it also can be below the countertop as long as, again, it's not more than 12 inches below, and it's not under an inner overhang that is more than 6 inches from the base. If it isn't, then we can put it down on the side, okay? And that's what it tells us right here, okay? The location of the 2 required island countertop receptacle outlets has been determined by the building owner. Put them anywhere they want on this island. There is no rule about being within 24 inches of this in it. It's wherever they want to put them in here. Again, sometimes these are really fancy islands, so you have to be very careful where the placement's going to be, that type of thing, right? But one of the things that we're going to take a look at real quick, and I'll finish this part on the G right here, and then we'll kind of go look at the code. G being, let's see here, G is right here. Notice that this one's for the wall, all right? Check this out. Another reminder, this receptacle has not been installed to serve the countertop surface. It is installed to meet the wall spacing requirements in 210.52a. It has nothing to do with the countertop. But since that receptacle is within 6 feet of the top inside edge of the bowl of the sink, guess what? It may be the living room, but it's required to be GFCI protected. And remember, the measurement is from the top inside edge straight as if it was a cord plugging in. Okay, so across the countertop and then at an angle straight down to the receptacle. If that is within 6 feet, then this receptacle would have to be GFCI protected, even though it's not serving the countertop. It's serving the wall space. So important to remember those things, folks. Really is important. Okay. All right. So let's go into the code real quick, and so we can kind of look at this for the peninsula and kind of get a feel on what it kind of looks like, and to quantify why you keep hearing me talk about receptacle outlet or the outlet reference. So let's go to the code. All right, so here we are in the code. I'm going to go to 210.52c. So I'm going the wrong way. 210.52 right here. Here's 52. And I'm going to go down to C. Here you go. We're at C, and then I'm going to get down when we're talking about right here. Islands and peninsula countertops. Notice this is all grayed out. So this is where you get all your language. The first one, again, this applies to both islands and peninsulas. And then this one down here is specific to peninsulas, okay? And gives you all that information. Now, the receptacle placements, this is right here. This is called receptacle outlet location. Again, you saw it before. It can be on or above the countertop, okay, but not more than 20 inches. Right here, it says in the countertop or work surface, receptacle outlet assembly listed for use in the countertop. That's those pop-up style. It can pop up out of the countertop. They take up, in an island, they would take up drawer space, so typically not what we would use, but you could. And then, of course, the third one right here is the one that allows it to be below the surface. And that's what you're going to have on an island. You're going to have to go below the surface, right? Okay, so that's what it talks about here. Ironically enough, that's where that comes from. And so when you go back to the code, oh, wait a minute. I wanted to point out, I've got to point something out. I'm sorry. Notice right here, it says receptacle outlet. Okay, here, notice it says receptacle outlet. Why is that significant? Because the course talks about receptacles because that's what you're going to put in there. That's common sense. But I want to teach you something today. The receptacle outlet is the box, not the device. The box. Okay? Important. A 2-gang box is 2 receptacle outlets because you could put 2 devices in it. Important distinction. This rule is talking about the receptacle outlet. The receptacle is a device. The outlet is the box to which the receptacle, the device, will be installed. So when you see us talk about receptacles, that's because we know what you're actually going to put in there. So it's trying to simplify it for you, but I like to do that. And this is what I do when I do my one-on-ones with you, or when you come to my Wednesday night sessions. I show all these little nuances, right? Why is that? Why would I say that? Because basically, if I had this peninsula right here, let's come back real quick. And this is why I do this. If I had this peninsula right here, could I put a simplex receptacle, a single receptacle in there and still be compliant? Absolutely. Because it's all about the receptacle outlet box, not the device that I'm putting into it. Duplex, fine. Simplex, fine. Okay, probably going to always put a duplex in there, but kind of you get why I make that distinction. So in our course, we try to make it simple. It's, you know, a receptacle is going to go in there, but this is the kind of things that I talk about on my Wednesday nights because I like to get deep and I like to help you learn things that other people maybe just don't know. And that's why you get into a program like ours, structured program. Now let's talk about that mounting. Because again, I want to make sure that I hammer this home. Receptacle mounting below the countertop. Why am I hammering this home? Because in the 2023 code, this is not going to work. This is purely 2020, so pay attention. The receptacles installed more than 20 inches above the countertop or work surface, such as an overhead cabinet, are permitted, but they're not going to meet the requirements for the countertop receptacles. We've said that over and over and over again. So if I put a receptacle in a cabinet that's above a countertop, I can do that, but it's not going to meet my spacing requirement. My spacing requirement, those receptacles have to be within 20 inches, right? Okay. Let's talk about this one right here. So here you go. Here's a little island for you. Receptacles. Receptacles installed face up in work surfaces or countertops are not allowed unless the receptacle outlet assembly is listed for countertop or work surface applications. Okay, so it's got to be specifically listed for that application. Other than that, you are not going to have a receptacle in a face up position on a countertop, flat out. Okay. And where does that give you that? It tells you this in 210.52C32 as well as in 406.5E. Okay, it gives you that direction about that. So let's go on and look at it real quick. 210.52 C32. So let's just go there. Because I'm like you, I love going into the code and learning. So let's go into the code, 210.52, and we're going to go to C32 right here. Okay, so in a countertop, receptacle outlet assembly is listed for use in the countertops. shall be installed in counter. Okay. Now, we can have them in there. They're permitted, but these are assemblies that pop up. It's not necessarily face-up application. All right. And then what is 4006.5e? Let's go look at that. Let's see here. Well, we're going down into 406. I'm going to keep scrolling. There we go. 406.5e. Let's go look at this. Went too far. Right here. Receptacles in countertops. What does it say? Receptacle assemblies for installation in countertop surfaces shall be listed for countertop applications. Remember what I said earlier is that I can't use those pop-ups that have a cord and plug on it. That's more like a relocatable power tap. They have to be hardwired, and they're going to be listed for this. Okay. Now, it says where the receptacle assemblies for countertop applications are required to provide ground fault circuit interrupter protection for personnel in accordance with 210.8, such assemblies shall be permitted to be listed as GFCI receptacle assemblies for countertop applications. Okay? So, can I have them in it? Absolutely. But what about that face-up application? Okay? I can have them in it, but check this right here. Position of receptacle face, right? So again, it talks about all this type of stuff. And, so let's see here. Now that's face up. That's something else. We don't want to talk about that. That's another episode. I was going to go there, but we don't want to go there. Just keep it. So if you're going to do, there is no, you do not install them face up unless, of course, they happen to be listed for that. And I don't know of any that are listed for face up. Okay. Now I know some that pop up. I know some that come up like that. But again, none that are actually going to be face up like that. Now we have floor receptacle ones that are face up. That's perfectly fine. Also know that under a counter, you can't have a receptacle face up under a counter. Inside a counter where you would have the plumbing under the sink, you can't have it face up either in the 2020 code. All right, where was I at here? Let's go back to the code real quick. All over the place. All right, B right here. So this is a receptacle. This is flat across the top. So the code allows me to go below the surface. All right, this says GFCI protection is required for all receptacles installed to serve the kitchen countertop surface. So yeah, even though it's an island, if it's installed and it's to serve the countertop, even if it's below the countertop, which the code allows us to do, still got to be GFCI. Makes sense, right? All right, what about C right here? Although receptacles located more than 12 inches below the countertop or work surface are permitted, so yeah, I could have one down lower, but they're not going to meet the requirement to serve the countertop because they can't be more than 12 inches and they can't be under an overhang that is what? More than 6 inches. Okay? So extends more than 6 inches and I couldn't put the receptacle under here. At least the one to serve the countertop, I couldn't. Could I put one down here? Maybe this is dividing the living room from the kitchen. Well, then you got to be really careful because if this receptacle here is to serve this island, an inspector could consider this a room divider, and it could require a receptacle on this side to serve the living room. And if that's the case, it can't be on that small appliance branch circuit, so it would have another receptacle down here if that inspector considered that to be a wall space. Now, when would an inspector maybe consider this to be a wall space? So let me give you some little inside help here. If your island is made of cabinets, and the countertop just sits on a cabinet, then it is not wall space, okay? If it actually is a wall that's built and they kind of frame up a 2x4 wall and then they push cabinets against it, then this is wall space. And it could be subject to normal 210.52a receptacles. And of course, you'll be putting in a receptacle to serve the countertop, okay? So you might have two here. But remember, this receptacle to serve the countertop cannot serve the wall space, okay? So the construction of the island can make a big difference, okay? So if it's just cabinets there with the top on it, it is not a wall, and I would not consider it wall space. But if it's a framed up wall and you're pushing cabinets to it and you're putting a counter on it with an overhang, and so basically if you go into construction and you notice they frame it up, my house was like that. It was framed up. Then that's a wall. And if that wall is facing the living room, that's wall space. If it's even in the kitchen, if it's 2 feet or more, it's wall space. Okay? And if it's in the kitchen, then it could be on the small appliance brand circuit. See how the code, you got to know these things. And we cover it in our course. So if that sounded confusing to you or I didn't explain it to the point where you're like, I don't get it, we cover that in our course. We can answer those questions on Wednesday nights. That's why you want to check out my website and get in our program. Now, they could have put it here on the side. If this overhang was more than 6 inches, then you just stick it over here on the side. But every part of this receptacle can't be more than 12 inches below the countertop surface. Okay? So here you go. Now, again, this receptacle, we'll talk about D right here. Here's the overhang. Receptacles mounted in the cabinet are permitted under the overhang of a countertop or work surface, but are not counted as required countertop receptacle where the countertop or work surface extends more than 6 inches beyond its support base. Okay, so this is the support base, and this is the edge of the countertop. If this measurement right here is more than 6 inches, then I could not put a receptacle under here to serve the countertop. But that does not mean that I could not have a wall space receptacle. That would be okay as well if that was a wall. Okay. Okay. Just kind of wanted to throw all those things out there. Now here you go. The peninsular counter side without doors or drawers might be considered wall space by the authority having jurisdiction. If so, and if longer than 6 feet, a receptacle is required. But I'm going to be honest with you. If they consider it wall space and it's at least 2 feet, they're going to make you put a receptacle. So again, work with your AHJ, and I'm just giving you some insight. This right here, I would argue, is not a wall space if it's simply sitting on 2 cabinets. If it's a framed up wall, chances are they're going to argue that that is wall space, folks. So just little things that you learn. Okay, that's it, folks. So I've kind of covered the spacing. It's taken us multiple videos, but we've covered all of the spacing requirements for bedrooms, living rooms. That's a different video. We covered the kitchen receptacle layouts. That's another video. And in this one, we covered peninsula and island layouts and how to calculate them out. Covered quite a bit. Hopefully you got something out of that. Remember, if you really want to learn the National Electrical Code, do me a favor. At least go check out the website. We've got a lot of blogs. I've got page after page of blogs with really good content for calculations. They're all free. At least do me a favor, check them out, right? We have some free courses on there that you can check out. But if you really want to get into a program to learn the National Electrical Code, maybe it's pre-licensing, you're trying to pass an exam, go to our website and look at our Fast Trax Black or our Fast Trax Plus. Now, what's the Plus? It's the same as the Black program. You'll get all of the good information. You'll get to come to Wednesday nights. But the Plus means you get access to special videos over on fasttraxtube.com. Okay, that's an annual subscription. But if you become a member of the Plus, you get access to it for an entire year as part of your package. Okay. Now, if you're already licensed and you're like, well, look, guy, I'm already a journeyman or I'm a master and I do nothing but residential. Hey, why don't you deep dive and become that superstar when it comes to residential? Well, how do you do that? You get in our Fast Trax Red program. It deep dives into every room within a dwelling, services, grounding, all the things that you need to know with residential wiring. That program covers it. What about commercial buildings? We cover that in the green program. Maybe you're in the industrial sector. We cover that in the blue program. Maybe you want to learn about grounding and bonding. We've got a purple program. Grounding and bonding is one of the best courses you're ever going to have. You really will learn it. And of course, you still get access to Wednesday nights if you want to come and ask any question that may confuse you. I'm here for you, folks. So hopefully you get something out of it. Go check out Fast Trax Tube. Check out fasttraxsystem.com. Watch the demos on some of our courses. And if you have any questions, all you got to do is go to the Contact Us button on the website, and you can send us any question, and we'll be more than happy to answer that for you. All right, folks. God bless. Until next time, stay safe. We'll catch you in the next video.
Morning coffee, vanilla latte, served to go. I drink it slow. Morning coffee, vanilla latte, served to go. I drink it slow.
Hey everybody, Paul Abernathy here. Welcome back to another episode here at Electrical Code Academy. I'm your instructor for today, and we're going to be talking ampere ratings of receptacles. Pretty important topic because I get quite a few questions about things like, well, can I put a 20 amp branch circuit on a 15 amp receptacle? Can I put a 15 on a 20? 15 amp receptacle on a 20? Can I put a 15 amp branch circuit on a 20 amp receptacle, and all those little nuances? We're going to talk about that today. We're going to get the air clear when it comes to the ampere ratings of receptacles and what you can and what you can't do. And I'm going to give you a little bit of information as we go about the different circuits that are required to be 20 amp versus what could be 15 amp. And maybe you're an electrician that does everything in a house in 20 amps when it comes to the 120 volt receptacle applications. So branch circuit applications. So maybe that's what you do. But again, you're going to see there are options. Also, before I get too deep into it, I want to remind you, if you're struggling with learning the National Electrical Code, that's what I'm here for. This is what I've dedicated my life to. For the last 32 years, I have been working with people to learn the National Electrical Code. And I was able to team up and partner to build a platform that allows me to be able to make it as simple as possible for you to learn the National Electrical Code. Also give you access to me on Wednesday nights so you can ask me questions. That's part of the program. You can get access to me and ask me anything you want. And our courses are set up that it basically gives you 24/7 access for 365 days, a whole year, that type of thing. So if you're interested in learning about our courses, if you want to do exam prep, that's the Fast Trax Black. If you want to get exam prep, but you also want videos, then that's the Plus. So you get the Black Plus, you get 12 months access to fasttraxtube.com. And it's kind of like YouTube, but it's Fast Trax Tube, and that's TRAX and TUBE, or maybe fasttraxtv.com if that's what you prefer. And those videos really go into a lot of detail, much like this video. We're going to have a bunch of them coming. It's not just me. We're going to have other educators on there. That platform is not designed to be just me. It's going to have other well-known educators' videos on there. And so you're going to get a well-rounded collection of videos that are all filtered by me personally. I review them and determine whether or not they're adequate for the channel. And so, again, if you haven't subscribed yet, go check it out. But if you get the Fast Trax Plus, you're going to get a year access anyway. Okay, so that's at fasttraxtube.com. If you need a good prep course, right here, go to fasttraxsystem.com. Now, if you're already licensed and you really are struggling with understanding, or you want to reduce the learning curve for residential wiring, commercial wiring, industrial wiring, then we have courses for you. That's the Fast Trax Red, the Fast Trax Green, and the Fast Trax Blue. All available on our website. Those are post-licensing. They help you deep dive into residential, commercial, industrial wiring. But we also have grounding and bonding. One of our most popular courses is the Fast Trax Purple. And that is all about grounding and bonding. And it is an amazing course. So if you're interested in that, we'd love to have you as a customer. And we value you and we appreciate you. And you can get more information. Even demos are available right there on this website. Just go there, click on courses, look at whatever course you want. And if there's a demo available, watch it, because you'll learn a lot about our programs by doing that. Okay. All right, let's go on and get into the material for today. And let's just jump right in. So we're going to be talking about ampere rating of receptacles. It's, again, a very important topic that sometimes gets glossed over, but on our Fast Tracks program, a lot of the competency reviews have these little questions. And again, statistically, a lot of people get these questions wrong when it comes to ratings of receptacles. So we're going to try to clear the air here and give you a little knowledge about it. And you're going to walk away, hopefully, with a little bit more knowledge of the ratings of receptacles. Okay? All right, so let's look at it here. And of course, as always, we're going to do a little bit of a lesson up front and talk about what circuits in a house, branch circuits in a house, have to be 20 amp, and then which other ones can be 15 amps. Understanding that you could do the whole house if you wanted in 20 amps. Obviously not the larger loads like ranges and whatnot. They'll have their own calculations, their own receptacles, their own ratings. But we're talking about general purpose and things like that. If you want to do everything in 20, you could. But we're going to talk about what's required to be in 20, and then everything else could be 15 amp when we're talking about general receptacle applications. So here we go. So we're going to be talking ampacity or ampere rating of receptacles. And I'm just going to read you some content. Again, great content, and this is available in our Fast Tracks program if you're a student. Receptacle branch circuits must have a rating of 20 amperes for laundry areas, bathrooms, garages, kitchens, obviously except for the refrigerator equipment supplied from an individual branch circuit at 15 amperes or greater. I'll explain that in a second. Dining rooms, pantries, breakfast rooms, and similar areas to all of those I just mentioned. Those all have to be a 20 amp branch circuit. So there's no ifs, ands, or buts about this. All those areas have to be a 20 amp branch circuit. And of course, the laundry and the bathroom are covered in 210.11c and covers each one of those. Garages is also there. And then, of course, in kitchens, again, that's covered there too. Now, let's talk a little bit about this here. The except for the refrigeration equipment supplied from an individual branch circuit rated 15 amperes or greater. Okay, so let's talk about that part of it. Now, let's go on and get rid of all that. We'll just highlight this here about that. All right, what are we talking about here? So it's very common for, let's say we have the minimum of 2 small appliance branch circuits. That's defined in 210.11c1. But in there, what if I want to take an individual branch circuit to just the refrigerator, right? I can do that. And it could be a 15 amp. It could still be a 20, but it could be a 15 amp rated branch circuit. Now, a lot of that's going to depend on whatever the nameplate says of the refrigerator. Obviously, if you're doing a Sub-Zero in a multi-million-dollar house, it might be larger, but you could run. There's nothing wrong with a 15 amp, branch circuit going there. That wouldn't be a problem. Okay. But everywhere else in that, what I just talked about, would all have to be 20 amp branch circuits. Now, those are required to all be 20, except for the individual branch circuit to the refrigerator, if that you choose to do that in your design. If not, also, typically the refrigerator is supposed to be, it says that in the code, that it should be on the small appliance branch circuit. But there is an allowance for it not to be, right? And that's under the exception, and that's where it could be 15 amps. So people put the refrigerator on the small appliance branch circuit all the time. That's what I used to do. I never ran an individual branch circuit for the refrigerator, and I never had a problem at all. Okay? It's not like you think that they're going to be plugging so many things in this countertop that there's not enough diversity that that's not going to be a problem. But sometimes people he and haw about it, and that's your choice to do that. That's totally up to you. Now, throughout the remainder of a one-family dwelling, then we could use 15 amp rated receptacle branch circuits everywhere else. That would be, for example, bedrooms, basements, living rooms, hallways, all those type of things. No problem being 15 amp branch circuit. And if there's receptacles in there, they most certainly could be 15 amp rated receptacles, and that's not a problem, right? The 20 amp stuff, that has to be where it has to be based on the code. But everywhere else, hey, there's nothing wrong with 15 amp branch circuits. That's perfectly fine. Now, going a little further here, lighting and receptacles can share the same branch circuit except for small appliance receptacles, garage receptacles, bathroom receptacles, unless the circuit applies a single bathroom, and I'll explain that in a minute, and laundry receptacles. All right, so this is pretty common, right? How many times have you ran a branch circuit to the bedroom, you looped around the bedroom, then you pop up to the switch, and then you put the light in the bedroom on the same circuit as the receptacles? It's perfectly fine. It's acceptable. That's totally acceptable. But you know what? There are applications where you can't. And as you see here, you can't do that when it comes to the small appliance receptacles, the garage receptacles, bathroom receptacles generally, and laundry receptacles. They cannot be on the lighting. They just have that branch circuit serving those receptacles, okay? That's the way that would go. But everywhere else, the bedrooms, living rooms, things like that, perfectly acceptable to have the lighting and the receptacles on the same circuit, okay? Now, let's talk a little bit. I'll get rid of this. Let's talk a little bit about unless the circuit supplies a single bathroom. What are we talking about there? All right, so if I take a 20 amp, we saw that that's required, 20 amp in the first sentence we looked at. If I run that 20 amp branch circuit to that bathroom, okay, I'm going to have the receptacles in that bathroom on that. And the ones that are within 3 feet of the basin, again, that's the one serving the countertop. That's where that 20 amp branch circuit's going to be supplying. If that branch circuit that I ran to that individual bathroom stays in that bathroom, in other words, it doesn't branch out to another bathroom, it just goes there and stops there, then I'm allowed, under the exception, to also do the lighting, for example, in that bathroom. So I can put everything within reason. Obviously, if we have a heat light combo, then we have to worry about the amps of the heat light. But in general, just keeping it very high level, I could put the lights and the receptacles on the same 20 amp branch circuit as long as it doesn't leave that bathroom. Now, if you happen to be supplying that bathroom's receptacles and then you're going to pop out of that bathroom and hit the receptacles in another bathroom, then only the receptacles can be on that 20 amp branch circuit. You couldn't put the lighting on it. So you're just going to bring a different circuit for the lighting, or the lighting in the bathroom is going to be picked up by the bedroom or whatever. Okay, nothing says the lighting has to be exclusive inside of the bathroom. Okay, so that's important because maybe you have a very simple dwelling and you want to take a 20 amp branch circuit to that bathroom and you want to pick up the lighting over the vanity. Maybe the exhaust fan pulls very little. Maybe that's what you want to hit, and you just run one 20 amp branch circuit and you're done. You're not leaving that room with that branch circuit. Then you're allowed to do that. Put the lighting and the receptacles on it. But the moment you leave, that circuit leaves that room to hit another bathroom, let's say, then you've got a problem. Then only the receptacles can be on that circuit. Make sense? All right, so that's what that rule's talking about. And then, of course, in Unit 7 of our program, for those that are actually in the program, we go even more detail about receptacles and lighting and specific areas and all that, all covered in Unit 7. So, look, if you're liking what you see, you're liking the detail, you like the illustration, the graphic, man, think about our program right there. Just go and watch the demo. It pretty much sells itself. Not only do you get my support, and if you want to know who I am, just go to the front of the National Electrical Code. You'll see my name under Code Making Panel 5, and you'll see my name under Code Making Panel 17. So I am not a fly-by-night YouTuber who just created this stuff out of the air. I've been doing this since all the way back in 89, and when I started doing some recordings. But I really got into it about 2004 when I started creating websites and putting things online and other listening repositories. And that was way before the YouTube grew up and all these other things blew up. So I'm not new to the game. And Google me a bit. You'll see that I love teaching people the National Electrical Code with a passion. It's what I love to do. It's my favorite thing to do, is to be able to live vicariously through all of my students. So if you like what you see and you want to join our program and really get into a good community, check that website out. And Unit 7 will go into a lot more detail. You see, this is a lot of detail. We go into a lot of detail, calculations and everything, okay? All right. So let's kind of go down this list here and kind of look at a few things here. All right, A, What does A mean? Look at these graphics here. Okay, A, receptacles installed on a 15 ampere circuit must have an ampere rating of not more than 15 amperes. Where does it say that? It says that in table 210.21b3. Okay, so we're going to highlight that. And what do I tell folks when you see the chevrons? Do you know what I tell you? What do I tell you? You go to the code book. So we're going to go to the code book. And we're going to go to 210.21b3. So I'm over here and I'm 210.21. And we're going to, that's 310.21. Let's go back. I'm not even in the right article. So let's get where we're at here. All right, 210.21. All right, 21. And we're going down. Here's B for receptacles. And we're going down to B3 right here, ratings. Okay. Now, notice where this says we're connected to a branch circuit supplying 2 or more receptacles or outlets. I want to point out something, just so people are aware of this. In this illustration right here, you see this duplex receptacle right here? Duplex. That is actually 2 receptacles. One on the top, one on the bottom, configured on a single yoke. Okay? So that is basically 2 receptacles. That's why we call it duplex receptacle. 2 receptacles. So when you look back at the code, it said supplying 2 or more receptacles. One duplex receptacle is 2. Okay, so we want to make sure that you hammer that home. Okay, most certainly hammer that home. That's going to be information that's very beneficial for you. So here's where we're at, and we saw that, and it tells us we're connected to a branch circuit supplying 2 or more receptacles or outlets. Receptacle ratings shall conform to the values listed in table 210.21b3. Okay? All right, so that's what this table is right here. So I'm going to blow this up and see if it comes out okay for us to work with it. Yeah, it does. It works good. So if we were talking about a 15 amp circuit, that would be this right here. Then the receptacle rating right here, not over 15 amps. So a 15 amp branch circuit, the maximum duplex receptacle that we could have on this is 15 amperes. Makes sense? So you're doing that bedroom, and you're going to be doing it, and the bedroom obviously is going to be AFCI 210.12a is AFCI requirement. Bedroom is in that list. And they're 15 amp receptacles. Then it would be a 15 amp rated overcurrent protective device and a 15 amp rated duplex receptacle. Makes sense? All right, we'll leave that there on the screen, and we'll go back to the code material so we can kind of look at it. All right, next one, B. Let's look at this one. Uh-oh, we got a big no-no through here. What does this say? A 20 ampere duplex receptacle shall not be installed on a 15 amp branch circuit. Okay? Oh, this is so important. So this right here is still a 15 amp breaker. Whether we want to argue the semantics of it or not, you absolutely cannot put a 20 amp rated device on a 15 amp rated branch circuit. Now, me and you know that the guts inside of that 15 or that 20 amp is exactly the same. The only difference is the faceplate. You got the little notch in the neutral side here of the faceplate to signify that it's a 20 amps. Plus, it'll be marked 20 amps. And this is a NEMA configuration faceplate. But you can't do it. Okay? Even though you think, well, Paul, wait a minute. The 15 amps is limiting it. Why can't I put a 20 amp receptacle on there? You can't. And people hate when I say this because the code says you can't. And people are like, I don't accept that. Well, the other thing is it sends a message to folks that you can plug things into this 20 amp receptacle and expect to get 20 amps out of it. And you're not. You're only going to get 15 amps out of it before that overcurrent protector device, trips off. Okay. So the code says we can't do it. So again, don't put a 20 amp receptacle on a 15 amp branch circuit. Put a 15 amp receptacle on a 15 amp branch circuit. Okay. Makes sense? All right. Let's go to the next one. So we're at C. All right. This is interesting. So C shows a 20 amp breaker. And this is where people will start to lose it. You ready? So I can't put a 20 on a 15. But here's a 20 amp rated devices, and I can put a 15 amp rated receptacle on a 20, Sounds weird, doesn't it? But that's what the code is. And I can put a 20 on a 20. So this is perfectly acceptable. Now, we'll go down and read C real quick. So here, it says receptacles installed on a 20 amp circuit can have an ampere rating of either 15 or 20. And that's what it says in table 210.21b3. So we'll go look and verify that. Well, here we are. And it looks like right here we see 20 amp circuit. And it says 15 or 20 right there. So if it's a 20 amp branch circuit, I can use a 15. Now, me and you both know that the internal guts are exactly the same, right? But that is just exactly what code tells us that we can do. And you can argue the semantics if you want, but at the end of the day, it is what it is. And you have to respect it. All right, well, let's go look at a couple more here because I don't see the other, and it's probably on this page. Yeah, they're all over here. So we'll probably be jumping back and forth, but I'll do my best to kind of illustrate these for you. All right, so let's get to D. Okay, here's where people start to get lost again. So this is a simplex, a single receptacle. All right, so this is a 15 amp rated breaker, and this is a 15 amp rated receptacle, and it's a simplex, and it is a receptacle. It's just one receptacle. Okay, so we call this a single receptacle. But again, in the field, people refer to this as a simplex receptacle, whereas a duplex is 2, a simplex is 1. Okay, as corny as that sounds, that's what it is. So let's go look at D real quick, right here. Here's what D says. It says a single receptacle installed on a branch circuit with no other devices or outlets. Okay, so it's not 2 or more, it's just 1, shall have an ampere or an ampere rating not less than the rating of the circuit. All right, why is that so important? So this single receptacle, this branch circuit, no other devices are on it. It's just one simplex. That's all it is. Okay, that receptacle shall have a rating not less than the rating of the circuit. Okay, so in this case, it can't be less. Now, could the receptacle be a 20? Right? Well, it's not less than the rating of the circuit. So absolutely. But typically what people do is it's a 15 amp branch circuit. They say 15 amp simplex. God, I can't even say it today. All right, and where do you get that rule? Right here. That is in 210.21b1. Again, pause, go look at your code book. This one we're not going to break away and look at because basically it says exactly what you see on the screen, so there's really no reason for me to go look. But if you're in the program, what do I say do? And I'm doing it for time, but you want to pause it, go read the rules so that you know that you're crystal clear about it, and then come back. All right, next, let's go on to the next one. So that was D. So remember what I just said? What about this 20? Can I put a 20 on a 15? Absolutely. Because as long as the rating of the receptacle is equal to or greater than that of the overcurrent device, when it comes to these simplexes here, absolutely, I can put a 20 amp single on a 15 amp, okay? Now, of course, I could put that single 20 on a 20. That should be a no-brainer. But here, the more significant to explain that on a 15 amp breaker, I can use a single 15 or a single 20 on that, and I would be perfectly acceptable to do that, right? Again, as long as the receptacle's rating is at least or greater than whatever the overcurrent protected device rating is, okay? And also remember that the rating of the overcurrent device dictates the rating of the circuit. Okay, this should go without saying, but in case you haven't heard it before, if it's a 20 amp rated overcurrent protected device and it's a 20 amp branch circuit, again, that's what dictates it. All right, now here's where we start seeing those other things right here. So what about now it's a 20 amp, just like up here where it said, well, wait a minute, this 20 could be on a 15 amp, but down here, this 15 can't be on the 20. Why? Because what did it say in 210.21? It says the receptacle has to be equal to or greater than the branch circuit rating. In this case, it was 20. So that 15 is not going to work, right? Now, you could do that with a duplex, remember? You can't do it here. That's what it says. And that is the part that I think people struggle with when they're determining what you can and can't do for the ratings of the receptacles versus the overcurrent protection. Okay, so that'd be a violation. And if we go look at F, you'll see right here, it says a 15 ampere single receptacle shall not be installed on a 20 amp individual branch circuit. Why? Because as it says in 210.21, the single receptacle has to be what? Equal to or greater than the branch circuit rating. And it is not in this case. All right, let's go on down here. Y'all doing great, and we're making great progress, and hopefully these are starting to now make more sense to people. All right, let's go on here. And all right, so here's a 20 amp rated overcurrent protective device. It happens in this case to be probably either a GFCI or an AFCI. Okay, could be dual function, does both. And you see it's a 20 and a 20 single is perfectly acceptable, right? And then down here, you see, again, like we saw before, 20 ampere rated overcurrent protective device and a 15 amp rated receptacle. Again, that's perfectly okay. We saw that earlier, but we have two additional callouts here, and so we want to make sure we look at these. So this is G and H. So let's see what G and H has to tell us. G says a duplex receptacle is not a single receptacle. Wow, that is so important again. So I have a lot of times students will be confused when they think of a duplex as a single receptacle. It's not, it's two. It's two, very important. Okay, so it is not a single receptacle as defined in Article 100. It says a single receptacle is a single contact device with no other contact devices on the same yoke or strap. Okay, just one receptacle. That's it. It's not a duplex. And I think one of the key things for people to really grasp is anywhere in the code that it says two or more receptacles, you have to remember that a duplex is two. And it's going to trigger some requirement maybe that talks about two or more. One duplex receptacle kicks that in, right? So that's so important to hammer that home, that a duplex, again, is not a single receptacle. Although it looks like a single receptacle, it's one receptacle device, but there's two receptacles on that yoke. Okay, whereas, again, simplex, just one. I hate to be redundant, but I understand that sometimes it takes that to beat people in the head to make them realize these things so that in the field they don't make these mistakes, and they certainly don't make them on an exam. Now, H says receptacles of the 20 ampere circuit can have a rating of either 15 or 20 amperes, and of course we saw that earlier, so all that was doing was reiterating what we saw up here, right? Reiterating what we saw right here. So that is nothing new. Okay, same thing we saw before. Makes sense? This can tend to get complicated for people, but if you just take a break and read it, and definitely look at table 210.21b, and most certainly B3, because that's your receptacle ratings, right? And then, of course, don't forget single. Okay, simplex ratings, and that would be in 210.21b. You definitely want to make sure you look at that as well. And we're going to go, now that we're done that part, we are going to go look at that one and kind of hammer this thing home. So remember, this is the one for the receptacles as two or more, right? And that's what we're talking about, B3 right here. Okay, two or more. And then the single is right here, B1. Single receptacle on an individual branch circuit, okay? Single receptacle. Make sure you're familiar with these. In an upcoming episode, we're also going to talk about things like cord and plug connected loads. We're also going to talk about permissible loads when you have multiple outlets, okay? And that would be like duplex here. It says two or more outlets or receptacles. That's a duplex. That's two or more. We're going to get into that because that is another place that people struggle with. And that is where we get into the 50% rule and the 80% rule, cord and plug connected versus fixed. Don't worry, we're going to cover that. And that's why you really need to make sure that you subscribe to our channel because other people just kind of give you information. I'm going to break it down for you. And I'm going to tell you that if you're wondering about trusted sources, again, I implore you folks, go to your code book. Go to the front of the code book. Go to code panel 5 and code panel 17. You're going to see my name in there. I've been doing this for a long time. I've written numerous books, and this is what I do. And so when you're investing in somebody and when you invest in us, I'm here to educate you. And that's what we're here to do. Okay, so let's kind of come back to me and we'll end this thing up for this episode. Hopefully you learned something. You now have a better understanding of receptacles and how they work and all the things that are associated with that. In future episodes, we're going to get deep into other topics. But again, if you want a good course on the National Electrical Code, you need it, right? If you're an electrician out there and you're just pulling cable, you're pulling conductors in raceways, and you're doing what the boss tells you, you're doing what your supervisor tells you, knowledge is powerful. You separate yourself amongst everybody else. The more knowledge, and let me tell you what, with knowledge comes a lot of pride. But with that pride becomes responsibility to pass on the knowledge that you're gaining to others. So tell people about our programs. Let them know about Fast Trax Tube to watch our videos. Get them in a good code-based program that teaches the National Electrical Code, not opinions, the National Electrical Code. That's what we're here to do. And again, we're here to try to help you understand it. So hopefully you got something out of this today. Until next time, folks, stay safe. God bless. Until next time, stay safe. All right? Take care.